Hello. It is time. Hello, ATB. I am alright. How are you? Okay. So, this is off stream, but I was talking with this guy trying to figure out what I can do for... I mean, okay. No matter what, it's kind of only a plus if this can avoid doing this call. It's only gonna be a positive. The issue is figuring out how to even keep track of that data, because the way that it's currently set up, can I reload that? I don't know why this is not color. Oh. Yeah. That line is not a real line. Okay. So, I will say this. I don't like how they've set it up, where essentially whenever you... For whatever reason, the screen resizes. Right? For whatever reason. The screen resizes, and instead of there being like a generic method that's like, hey, the screen is resized, it calls free data, and then it calls configure. On wrong place. On Godot's side, or GD script land, that doesn't happen. You just get a render callback and you have to check to see if the screen is resized. So if the screen is resized, then you got to do some stuff there, which at the very least that seems to be better than what they have, where if the screen resizes, somewhere up the call chain, it goes from either a resize or like an update or a reconfigure to a cleanup call to, or no, not even that. delete your information call followed by a set up call kind of thing. So in configure, this calls cleanup, somewhere around here. Cleanup goes through every one of these effects, I guess, and says free data. And then later, it calls configure on all of them. So, at least as far as like not having a concept of resizing the screen, maybe that's fine. But I feel like that's such a common thing to do, to say, hey, your buffers, or the screen buffer has resized. Do you care? And then an effect could say, yes, I care. Let me get it set up for the resize. Instead, every effect is just called delete everything, set everything back up. Or sorry, delete everything, then set everything back up. Kind of a waste of time, I think. But at least as far as like textures are aware, you can't resize a texture, you have to get a new one. At least I think that's how like most graphics APIs are. If you can resize, then that would be great, and I would probably use that instead. But I'm assuming you can't, which is why they just modeled that exactly. The problem here is that luminance and luminance buffers are totally unrelated. Weirdly enough, they do not actually have a concept of knowing about each other. Even though luminance buffers is a subclass of luminance, luminance does not keep track of the luminance buffers. It puts them inside of something called a render buffers, and then will retrieve it from render buffers for you when you ask it to. So at the end of the day, luminance doesn't own or have a connection to render buffers. You just say, here's some buffers, give me the luminance buffers. And that's how it works. Is that a good setup? I don't know. I think not. I think there should be a way to just say, hey, I'm a luminance, I have a set of buffers that I track. Here's the one that you want. Instead of saying, here's a box, pull out the luminance buffers for me, kind of thing. That just seems weird. Okay. So the problem here, ultimate problem, is that free data does not know if it is about to be reconfigured. So luminance buffers cannot actually hold on to any data after free data is called. It has to delete everything. The alternative to this would be to go into cleanup and like pass a boolean that says we're gonna reconfigure. So don't actually free everything, like treat this as a not a free, but that, I don't know. And that's just weird, right? It's already a bad API, or it's already a bad structure, I think. Hacking something on is probably not a good idea. So he has mentioned using SSBO, which I know what it is. It's just a buffer. The graphics API has no concept of what you're putting in there or what kind of buffer it is. You just ask for a size and it gives you a buffer of that size. So he mentioned that, and I'm like, I don't know how that solves the problem of the fact that free data has to delete everything. But luminance does not have a handle to luminance buffers, so it can't track data for it in that way. However, luminance does have some data. Luminance sets up a shader, and it accesses the render device and creates a shader, which is just, ultimately it's just saying, here's some data, and here's what I'm calling this data, and here's what you're going to call the data, kind of idea. So I think what I do is down here at the bottom, I just create a buffer of whatever size, I don't know, whatever size, and I just kind of treat that like an array. Let me go to the API for it. The API is weird. It's called create they're inconsistent with the naming. It's called storage buffer create, and typically you would think storage buffer get, copy, all this other stuff, but really then it's like buffer get data, buffer copy, buffer clear. I can't actually do get data because that synchronizes, but there's buffer update. I provide some data, I tell it where it wants to write, how many bytes it's going to write. Which actually, do I really have to tell how many bytes it's going to write? Updates a region of bytes if offset plus bytes exceeds the... Okay, well, whatever. Either way, what's going to happen is luminance buffers. On the bright side, luminance is responsible for creating them. It will create them. So it literally calls instantiate. And it calls configure and does everything. Luminance can keep track of an index and say, hey, here's the buffer RID, and here's your index. Whenever you write, I want you to write there. And whenever you read, I want you to read there. Copy, copy there, whatever. So Luminance can now hold onto some data that is not going to be freed until the whole Luminance thing is destroyed. Buffers can be cleared and freed and whatever. But then the buffers always have their ID. I guess the one downside is that okay, so there is a weird thing happening here where Luminance does not know when a Luminance buffer goes away. Because a free data could be just prior to a full delete. And I guess I'm not entirely sure of the last ones, because then this feels like it could possibly be a memory leak, where if we just keep creating new luminous buffers, then that could get bad. Though they are refs, which means they are managed data, so if they are no longer referenced, they will be destructed. So I guess I can just rely on a destructor there, then, can't I? I could have a destructor. The default is public render buffer custom data. Okay. One sec. Was I looking? Render buffer custom data RD. Okay. So it's nothing. It's barely even an interface. Jeez. It's barely an interface. I'm trying to figure out where the destructor goes. I guess... I think I need this no matter what, because... Well, I mean, if I'm going to do that, if I'm going to rely on the destructor to get rid of it, like if I have to have a destructor anyway, then I may as well just have it be a permanent thing that it tracks. It will track a last luminance and just save it whenever it frees. And then when it destroys it, will destroy it. Yeah, I mean, if I'm going to do that, I need to do that anyway. Let me find everywhere that free data is called. This should be the entire class that does it, but I think that free data is actually like not even called anywhere. They will be arrow operator. Right. Free data buffers, but don't destroy them. So for E in data buffers, so I want to see... I want to see everywhere that this is iterated over. Erase has custom data. Set custom data. Erase. Erase must just call the destructor. Okay. Okay, so the destructor calls cleanup and then deletes the buffer, which should result in erase being called. So I want to go to ref. I'm going to find ref. You know what? I bet erase is not called that many times. Okay. It's called a lot, but I like to find it in one place. It's definitely going to be in core, right? It would be in core. Okay, it's a header file. So... right. Let's go find it. Templates. What are they called? Resource? Resource would import it. IO resource. Resource. Core object ref counted. Alright, found it. Like, this... Something's wrong with their organization. Something is actually just wrong. Okay, so this is ref. Or maybe not. Oh, no, yeah, here it is. Ref. So, there should be an instantiate, which does like mem new or whatever. And there should be just the destructor. Instantiate mem new, destructor calls unref. Unref has a to-do. Reinterpret cast, unreference. If unreference returns... Oh, this is ref counted. If reference returns that, it calls mem delete. Mem delete should be the destructor. There's also just an erase. What does erase do? Erase probably just calls unref and then gets rid of the pointer. Erase. Oh. Oh, data buffers is a map and then it calls erase. Okay. Alright, I see how it works. And then it will just call, yeah, that will call a destructor. Mem delete. I need to be sure. I have no idea where this function comes from, but it's from somewhere. Okay. So we're just making up names. All right. A macro. What? That was so weird. I had to like hit that combo 4 times for it to work. All right. Define mem delete. If it is not trivially destructible. If not, pre-delete handler. Really? Okay. I was trying to figure this one out. So it's only object. And it just goes object underscore pre-delete, which I assume at that point goes off to virtual interface, virtual calls. Okay. All right. And then it just literally calls the destructor. I don't know why they call it P class though. This seems bad. All right, cool. So the destructor is definitely called. So if I'm actually going to have a destructor anyway, but also preferably, I'm probably not going to create 100 1 or 4 byte buffers to store a float. That would probably be preferable to not do that. This also doesn't have a constructor. All right, here's what I'll say. I'll just make the destructor because this is always wrapped in a ref. So there. Configure will look for if not last luminance is valid. So if last luminance is not valid, I'm gonna make it. We make it here. And then I don't know what their like trend. I mean, the trend should be that the destructors all listed right out, right? So I think that's how I would write that. RID. And then I don't actually have to do this, but I'm going to do it anyway. I really shouldn't have to do that because this is the destructor. So I'll just leave it. Okay. If it's valid, do that. I mean, I don't know. Isn't it like it? I mean, they don't clear these ones, so I won't either. I'll follow the code above. All right, so when we configure, also, you know what? I'm actually gonna put it up here. If this is final, I'll do a check here. And then when we create the texture, I call a clear last luminance. And then here, this should be like texture copy. We can copy to I'm gonna say I don't oh, I do have to copy from because then I have to copy it out of there, right? So they do have to share that. They have to be copy from and copy to. Texture copy. Somewhere down here they do a texture copy. Although they do a compute list, don't they? Oh, they don't do that. Okay, so I just get to run copy. Texture copy. From texture to texture, position to position should just be all zeros. Size must be size. That's a lot. From texture, okay. So I'm copying from into with vector 3 zeros. Let me see if those are available. I think just initializing vector 3 is a 0, right? Okay, I don't, yeah. Also, this is not the same thing, so I should probably look up texture copy directly. Wow. Okay, rendering device. There are no defaults. From to size? I don't know, it's just like this. Why don't they use a vector 3 integer? Why do they have to use floating vectors? Source map, destination map. So those, and then that should just be 4 zeros. Although texture clear, let me look at texture clear because there's ones in there. Base, total, base, total. Okay. So it should all just be zeros. Well, I say which map, they should be 0 indexed. So they should just be 0 indexed. Okay, so then I clear that one and then I copy that into here. Okay, and then I have it handled in the destructor, so we get rid of it. We create it the one time. And then down here in free data, before I run this, I have to do I guess this is where I could actually hold on to it, couldn't it be? Instead of actually freeing it here, I could simply move last luminance, move current into last luminance, because they technically point to an identical texture setup. So then I won't have to write any code in here. That's my idea. Hey, Danilin, read my comment on this. There's 159 comments. How am I supposed to find yours? Why are they favoriting every single comment that they have? Do you even have the same username? Oh. Okay. As much as I like your videos, this one bothers me because it's very lore inaccurate, as angels do not have the authority to forgive sins, and I can't relax if I am overthinking. They have not hearted that comment yet. Title of the video. Tired Angel forgives your sins. ASMR roleplay. F4A. What does that mean? Reverse comfort. I don't understand. Reverse comfort? F4A? Okay, so I don't need to... Yeah. I think all I do is... In fact, I might even just leave that line there, and I just say... If... Oh, please. Please. Is valid. Then I'm doing this. Otherwise... I really wish I didn't have to manually format everything. And then I just delete this line. I create the texture. If last luminance is valid, other way around. And this would be, whoops, 3 fewer lines. What did I just delete? I create the current texture. If we have a last luminance, I copy last luminance into mine there. If I don't, I clear the texture with the default luminance value. And then in free data, if current is valid, or well, if last luminance is valid, I delete it at this point, because it shouldn't be. And then if I have current, I save that to last luminance and then I just wipe current. And then I just create a destructor. If we have this, we're freeing the RID. Okay. I don't really want to close that one, so I'm gonna, but I don't want to close this one. Yeah, I think this one I'm just gonna try to make another joint work. I'm gonna try really hard to make another joint work, and then if that just super fails, then I've got to go back to the drawing board. Okay, so here's the real change. Well, hang on. Behind by 1 commit. Am right to get mad at that video. Sure. Yes. I can delete the include. No more marshals. So add a destructor. If last luminance exists, I delete it. I add a copy from because I'm going to need that. Because I use copy. And then... and then if this is the final one, I would be creating current, which is just a copy of the other one. If I had a last luminance, I copy that texture into current. If I don't have a last luminance, I clear my texture instead. And then under free data, if I have last luminance value, I delete it. And then I just move current into last luminance. I'm just adding a destructor. Right? Okay. I should not commit yet. I need to test this. Okay, I can git commit. I want to copy this commit message. No, I don't want to. I want to print. Retain current luminous result. Did I delete one character? I just hit delete key. Yeah, the reason I'm making a commit, but I'm not going to push it, it's just so I can get this, the ID. So... Did I copy the whole thing? And no, I'm missing the 9, because of course I am, because I don't know when this thing is copying the last character or not. In some contexts, if I drag over the whole thing, it copies also what's underneath the block, and sometimes it doesn't copy what's underneath the block. Annoying. I feel like it should not copy what's underneath the block, so then I can see the exact letters that I'm copying. But there's like one situation where it will copy the one underneath the block, and then it makes it annoying. Okay, so I've got that copied, so I'm going to switch to Planet Game. Check the log here. Fix flickering. So yeah, I'm gonna undo that. So I'm gonna do git reset hard head 1 because I want to drop that commit entirely. Good. I should have nothing. I'm gonna do git cherry pick that commit. Bang. And now I can do build a. All right. I am curious about GPU synchronization. When I call texture get data, CPU read bit? CPU read bit. Texture can be read back on the CPU using texture get data faster than without this bit, since it is always kept in the system memory. And then this searching doesn't work. I have to type it out anyway because, oh, it does work. Oh, but copying just like fails to render anything. Oh, CPU readable textures are unsupported on D3. Vulkan's fine with it. Okay. So I couldn't use that because it would lock me out of that. Okay, well, the GPU can read textures faster if they're stored in VRAM instead of the cloud. Yeah. Exactly what you just said. Silly Microsoft. D3, D12 is like DirectX 12, right? That's what that means, I'm pretty sure. What's the D3 for? It definitely is, because in order to use DirectX 12, you have to get D3, D12. I know this. I've seen it. It's built. I can run. Direct 3, that's what it means, right? Okay. Thanks. Direct 3D. Why do they have the extra D then? Oh, Direct 3D 12, right. Also known as DirectX 12. Alright, well, I can do that. I can do this. That's great. Let me do this while this is updating. Let me turn on FPS, frame time. Well, I mean, it changes because I'm making it larger and then the FPS drops a little bit, but... I mean, yeah, so 1000 FPS, this is just doing nothing then, right? So this has no effect on FPS. Great. Full test, I will run it, and then I will... The robot's freaking out. Oh, wait a second. I didn't realize that going wide increased the FOV. Wait, can I like see backwards? I'm making it super wide. I'm still growing the size of the screen too. What should I do this? This might be dangerous. Okay. Oh gosh. Kill it, kill it, kill it now. Okay. Yeah, I shouldn't be doing that. Okay. I was killing my graphics card doing that. The stream was dying. Yeah, don't do that. Do not infinitely grow the size of your screen, of your window. It's not safe. Alright, well, that worked. So, git switch. Fix auto exposure flash. Git push F. And that should update the PR. Go back to line again. Oh, and then I guess I have to do git push F here too. All right. Destructor from... Sorry, I'm not... I was wrong. DirectX is just a collection of technologies. Yeah. DirectX is the brand. Okay. 21 line changes. Wait, why does it do this? Oh, because 4 of them are here. All right. So if we have a last luminance, we copy. If we don't, we clear. Free. If we have a last, we delete it, and then we save current into last luminance. And then we just have a destructor that will clear last luminance if it's there. Honestly, I will say I'm kind of surprised that I was able to type all this out without even having a syntax error. Also, the fact that I guessed these correctly seemed fine. Well, how would I get GPU errors? Would that even happen? Video RAM? Wait, does this really work? I've never actually looked at this. Video RAM. What's in VRAM? Might this kill stuff? Oh, 11 megabytes. The smallest texture. A 2x2 texture. RGBA8. Wait, how are there actually so few? I mean, I guess that would make sense. I do have very few textures. But this has to be this has to be the texture then. But it's a 2x2 and it's RGBA, which doesn't make sense. Because that's not the format. It should be R8. And there should also be several of these, right? Huh. This doesn't seem right. Yeah, this can't be right. Is this... I don't... Okay, yeah, there's 100 megabytes in texture memory here, and then there's less than 12 here, so... by the engine? Why is it... Oh, if I go here, and then I go here and hit refresh, and then it's still no. The texture's not there. Also, I didn't know this was a thing. I can look at the physics process. Whoa. Real time? Real-time information? The invisible crawler? Okay. This is cool. I didn't know this was here. Well, I never opened this tab before. ObjectDB? Wait a second. Godot might be pretty cool. Godot might be pretty cool. All right, yeah, whoa. I'm making a joint. I'm making another joint. I'm gonna make it happen. What have I got? Hopefully nothing too much. Hopefully not too much. I think I was trying to say hopefully nothing crazy and hopefully not too much at the same time. And I blended the sentences. All right, so they're just going to target rotation. That's going to stay there, but that's going to also not stay there because I've got to... No, I can't teleport. Okay. I have to make it work. Either A, I remove a joint. If it can't, okay, here's what I'm gonna say. If I can't make this work, this segment of leg gets deleted, and then this just grows out to here. So I'm just going to remove this bone if I can't make it good. So that way I can still have the Z-axis rotation here and then the X on these two nodes. If I can't add the new joint, then it stay fine. And plus, doing that, okay, there is no plus. It's really only a downside that I lose this bit here. But I could still lie visually, because I do like how this bone curves down. I could still lie visually about that bone. The real bone could be straight out, but then I could have a fake curved bone that does this, and then have them like offset slightly so the mesh looks better. The mesh looks like how I want it to look. All right. Well, yes. Okay. So I need a new bone attachment for all of these. So I will start with this one. I do have to have another thing where I need to check each of these bodies to check if they collide with the main body when I initialize them. And if they collide with the main body, I have to add the main body as an exception. So I'm going to start by coding that in, because I'm going to need that right away. So when the physical skeleton is loading everything, it has to check. Well, it doesn't have to do this here. It can do it up here once it's done. Set up body joints. Iterate IK. Load attachments. Save all paths. Move everything. I do have the main body state this whole time. I don't know why I have the main body state. What is this for? Really? Is it not complaining that it's unused because this possibly has a side effect? Weird. Well, okay, how do I check if stuff intersects? It's probably direct space state 3D. I should not remember that stuff. Alright, I just want to know if there's like a simpler way to do this. I think I have to do the shapes. I have to compare all the shapes to each other. For the monster. Yeah. It's not a okay. Okay, fine. I'll just do it. I'll just do it. Is the build gonna work this time? I think it's all gonna work. The one that randomly failed has passed. It was like Windows with Clang. Yeah, this one like failed for some reason. And I have no idea why it would have failed. Okay. So for joint data in loaded joints, update all joint paths, store center of mass, and then here I'm going to if the main body is intersecting this body. Ensure it has... Ensure it has a collision exception. Is that a sign of something bad? Probably. I mean, I think it definitely is. It would be preferable that I don't have a joint body that just completely is entirely contained inside the main body, and so you can't even interact with the outside of the main body. I don't know, maybe that's just what I should do right away. Maybe I should just drop the joint entirely and not even attempt that. All right. I mean, that like, really? That is what I should do. I should just get rid of that joint. I should get rid of this bone. I should just merge these two bones. This bone will still have to... This whole set will still have to be a Z-axis only rotation. And then I think I just use a mesh thing so that the whole arm still swings correctly, which means this bone has to be flat. The Z has to be aligned with the body's up axis. But well, what does the main box look like? Where is the main box? I mean, yeah, I have this joint fully... I have that bone entirely contained in there. Okay, let me just do this. Let me just start with the... probably the easier one, which is just trying to see if I can have the extra joint. Getting the script to work. So joint has to... I need to obtain... I need to obtain the body, so... Joint data, body. Is there anything that I can just like check right away? Like I can call a function that asks if it collides with another body. There's test move. Alright, let's see what I get for rigid bodies. There is get colliding bodies, but this is something that I have to like... It's going to tell me I have to turn this on, and yeah, so it won't be for that frame. Because it doesn't actually, it hasn't done anything yet. So then, next step up is physics body, which probably gives me nothing. There's test move. Can a collision? Is that how I get the result? Checks for collisions without moving the body in order to be frame rate independent. Motion should be computed using delta. Virtually sets to that again transform, then tries to move the body along the vector. if a collision would stop the body from moving. Okay, so that's not helpful. That's not an intersection. That's a collision. I specifically require an intersection. Because I think the way that the collisions check is that the surface has to intersect. So if it is fully contained and I don't move it, there's no surface intersection there. Not really. But I mean, it might do that. I'm not going to trust it. I can just write it all myself where I just iterate through the shapes. And then I can, since I have the main body state here, which, I don't know, maybe I just had an idea. Maybe I just had a feeling. From weeks ago when I originally wrote this, that I would need to use it. Weeks ago? This is probably days ago. Main body shape. Shape. Shape owner. Get owner. Like, what is all this? Shape owner get shape owners. But then I need something that returns a shape, which gives me a shape 3D, which is not actually what I'm looking for, because a shape 3D contains a shape, which is not even there. It's not even listed. Okay. Or is it? No, because these would have to have an RID, and these don't have an RID. Okay, so I'm not looking for that. I'm looking to just get the thing. So I just get the thing. Well, actually, I think, hang on. Physics. Shape. Body get shape. Body get shape. Cool. Body get shape. Count. These should already be added to the scene. Yeah, because the main body would already be added to the scene. Or, yeah. So I do joint data. I think I need to at least keep the RID, so. It was suggesting body RID for a second there. Did I make this a general method? I'm doing this right now in Grenade. And what I'm really doing is I'm just testing if it intersects with a specific body. Also, this stuff is really dumb that it's still happening that I fire it and it still doesn't recognize it. Okay, I'm just gonna do that. I'm just gonna get the direct space state and then okay. And then I would have to do this, right? I have to get the body get shape transform. And I would do space. And then I need the query. Query has a shape RID, and then that. The collision mask is everything by default. I think I only have to intersect it with the collision layer of the main body. There's no exclusions. Collision mask will be collision layer of the main body RID. Because I'm specifically looking for an intersection with that shape. Okay. Intersect shape, and then I have to set query shape. I think I just run the query. And I have to give it max results 8. Just to be safe, but not too many. And then I iterate through all the intersections. So we'll hit in intersections. I'm checking the hit RID is the main body RID. So this one I probably just should save it. Because I've done it 3 times now. If I intersect it, then I have hit it. So I need to exclude it. So I will run break if intersects main body. This is why having named for loops for breaks is great, because I don't have to do this where I have to keep track of a boolean and go all the way out. I could just do it right then and there and then break the whole loop. Otherwise, I may as well do it at the bottom. If I intersects main body, then I would do joint data body. Add collision exception with main body. And I only had to do this if the parent is not if the parent is the main body. I skip over. All right. Also, you know what I think? I think this may still not do what I think it does. I think it might still return a false if it's fully contained. Because that's technically not an... Okay, it's definitely an intersection because it's contained. But it's not an intersection in the sense that there's a point that it happens at. But this also doesn't provide a point that it happens at. It just tells you where or what shape it was. Right. Okay. I gotta take the dog out. I'll be right back. I'm back. Alright, well, I'm just gonna pretend that I've done it right. Though if I find that it's not doing it, then I will have an issue. So I'm gonna go ahead and print out joint body Alright. So now that code is in place. No, I hide this. I'll leave that so I know which way is front and right. It'll be helpful. Though actually, I guess if I just look at the bones, I would know, right? That's front. Yeah, they point. Okay. So I'm gonna start by duplicating them. Front, right. I think that's the term. Okay. This needs to be renamed to that. This needs to be given a new unique shape. And I guess I'll probably go ahead and name these. It's probably a good idea. Okay. This needs to be renamed to front, right. And this will have... That won't be on, this will be on. And then motor, this will be off. That will be on. This will be off. That will be on. And I messed up. Well, actually no, I didn't mess up. I am technically updating femur joint right now. So I'm going to change this back to 500 and I'll reset these. Right, okay. Because, yeah, I remember now that this whole setup is for this. So now I'm going to hit make unique. I'm going to change the name to that. And then I should see this one should have taken on all those settings. It has. Awesome. Right, so I can see all the changes that are made. And now hopefully I've coded it correctly. And if I were to start making this one work for the other one, it does not. So it's just really flipping all those around. And now I go here and that looks correct. Those are the only changes. Awesome. I don't remember how this code works, to be honest. But it seems like it worked. So this connects that body. This connects femur to this body. And then this, these two boxes will now be different. So we're gonna just make unique. That's all I need to do for that one. This one, make unique, and that's all I should have to do for that one. Okay. So now I just need to reset the transform of this guy. Okay, no. I need to make this snap to that. It's active. Though it's also... Okay, now it's active. Alright. Go and hide these. Gonna make this shape roughly correct. Okay. So I check. The height is probably 0.8. It's probably 0.4. Okay. Looks right to me. And I'll just make it like a sphere. That probably simplifies some stuff. Though if I'm gonna make it a sphere, then I probably should just commit to making it a sphere. So I'll make it a sphere shape. And that's the same margin, so I should probably not turn off. I should probably leave the margins at 0. Okay. I'm just going to manually type it in again to be sure. This is in the right place. It has the right limits. It's connected from here to the main body. This joint is here to the bat. And I guess I will leave it. Yeah, I'm gonna have to leave the boxes, right? So this length is 0.8. But you know what? I will change it to... I won't. I will leave it as it is. Yes, I'll leave it as it is. Subservientghostface.com. What does that mean? I don't want to click that link. I'm afraid to click that link. Put your age and tell him to do something. What? I'm not going to do that. Yeah, I'm not doing that. I'll make you so gay. Sure I am. Alrighty. I believe I had it set up. But before I go any further, I'm going to I'm just gonna hit run and see if I get the printout telling me that it already intersects it, and it did not tell me that it intersects it, which is really sad because it should have done that. So do the shapes have to have 0 margins? Because I can do that. It should have told me. Does the query have a default margin? It's a default margin of 0. I think it doesn't intersect with it because it doesn't exist yet. It didn't even run that code. I put it in the wrong spot. Here. Go. So which one are we doing right now? Front left tibia? Okay, definitely not that one. Tarsus, no. I'm looking for femur. And all the femur should be intersecting. Well, I mean, it does skip it if it's like this. But there should be at least one front right. Okay, good. What the hell? It has that many intersections? Do I need to increase the number? This collides with it. No. No. Is that possibly why grenade is wrong? Well, I mean, grenade does it. Okay. Right. Intersections, joint. I'm looking for front right femur. I mean, in theory, it should be... Oh, also, the order of this... Is the order of this correct? Loaded joints should be organized root to end. Front left femur. Front left tibia. Front left tarsus. Front right. Okay, cool. It is. Very good. What are we looking at right now? Oh, if I just click joint, I can see it. Front left. Nope. Front right femur should be intersecting. Intersections. There should be like 2 or 3. 3, I think. One intersection. It collides with... That's main body. Awesome. And then I get the print. Joint body, front right front body initially intersects scroller about adding exception. Amazing. Okay. Well, I'm glad I looked at it. And that was a ridiculous number of intersections as well. It intersected everything. It had like all 8 intersections, and I think, or I didn't look at anything out of the first one. Oh man. The first one was the back right body. I'm like, what? How? You're literally not in the same place. All right, cool. Run. Front right initially intersects. Awesome. So, now that I have that, and I know that this is working, I need to add all the other ones. So I duplicate. I move it down to, it should be first in the list. Should be there. And this needs to be just above front and left. And now I rename it to front left. And then I have to update every setting every time. Front, left. And I will just click the skeleton to force the update. Front, left. That should be the same. Should be named left. And then I have to update the targets. So that one's correct. Node B is, that's correct. Well, those nodes are actually fine. But then this joint needs to change from crawler to front left. And these should already all be updated. All right, and it's just that simple. This should be the only one I have to update. Well, I click the skeleton and then I click... Okay, no. I forgot this. Middle right. Skeleton. And then the joint. This joint is fine. The femur joint needs to be changed. And then I'm halfway done. This should be good, and then I have to update this joint. Right. It's all there. And then it should just work. It just works, and then it just works, and then it just works. Front left, front right, middle left, middle right, and back left, back right. All good. Okay. Yeah, it looks great. I think it's doing exactly what I wanted to do. That. Update joints or motors is where a problem probably is right now, or is why it is doing this. So there's target rotation, which is just to get the bone pose rotation. If this is the case, I'm not going to do anything. I'm just going to ride a pass. You have to watch JoJo's Bizarre Adventures. It's peak writing. I've watched them all. I don't know if I would say peak writing though, but it's good. Okay, so what's the issue? There is an issue. Why is there an issue? Not peak, but good in my opinion. Yeah, that's exactly what I said. I think it's very TV. It's very TV. Alright, so what's wrong with the rotations? So I want to see a specific one that we're doing. Front left, that's the one that we're doing good. I get the target rotation. Sure. Angle? Joint data angle. Well, what's the angle? I probably should have left all the boxes on while I was testing the first leg, because I do think it immediately broke. Also, yeah, I'm just gonna comment this code out. I'm gonna use just the multi-line comments, a hidden feature. Yeah, joint data angles should be like the exact same thing right now. So target rotation is that. Joint data angle is incredibly different. And it is a value. Euler angles. -90, 45. 20. Am I calculating the angle correctly? Where do I calculate the angle? The angle is calculated here as being okay, so angle is the body's orientation. And then I set it. And then I get this callback down here from update motors, which just reads in the same values. So it is, so these are so dramatically different it is a mistake in this calculation. So if the parent is the main body, I get the bone rotation as relative to the parent bone. Okay, the rotation, the angle here needs to be in the bone's pose space. So it's actually a bit strange for this first one, because I actually need it as an angle relative to the main body's angle. So what I do here is I get the... Okay, I mean, this is just wrong. It should be... It should be the bone rotation, its rotation. Okay, this just needs to be like completely different. So, what's the initial rotation for? The initial rotation is not used for anything. Can we get serious and start telling me that I have these unused variables? Okay, so what I mean to do is I mean to get this, and then this would be that. And then if this is the main body, bone rotation will be, well, I think the first thing I do is I probably just get the bone pose rotation. Or, okay, no. I'm calculating it as a real value. Yeah, so I just want to skip that completely. So the bone rotation would be instead, I would take this one. It should be this body's rotation relative to its parent rotation, relative to the parent bone rotation. So I just have to obtain the parent bone rotation. Okay. So now this will just be parent rotation inverse body basis get rotation. And that's it. Otherwise, it would be... It's just going to be the relative rotations of the next body up. So... Can I use these? No, because I specifically have to get it relative to the parent's pose. But this is... I have to take this, do skeleton, global basis, transform that, so the rotations work out. Now I get the full global rotation, take the inverse, inversely transform it by this. Good. Bone rotation, when it's not the main body, is just the angle between the two bodies. So it would just be joint data, parent, global basis, inverse. What is joint body, joint parent? This is the joints transform relative to the parent. This is the joints transform. Is that right? No, I have the relative transforms. I take this. Okay, so yeah, this is like getting the... Okay. This is error stuff. This is not meant for that. So I just do... Wait. No, I think this is actually wrong. Should I be using these? No, because ultimately these two will map to the same position, is what this does. Those map to the same position. Yeah, so I'm actually just getting their transforms. I don't really have to get global basis there because I know it's global already. Then I don't have to do that either. I can just do basis. Maybe I should just do this. There. All right. So the first frame, I should see that these just have the exact same thing. So target rotation is still, you know, whatever that is. And then this one should read the same value. Those look really similar to me. Awesome. Okay. Run. It's very heavy now. It's actually getting too heavy. Okay, well, that's another thing that I have to figure out is the fact that it's obviously just too heavy all the time. It literally just cannot stand. Yeah, it's actually kind of barely able to stay off the ground. Apparently it's moving, but I don't see it moving. Whoa. Stood up pretty quick there. Okay. Alright, but I know that it struggles. So, now that I have that, I'm just gonna go ahead and turn these values up to kind of a ridiculous quantity, just so I can be sure I'm testing it at its best. And then I can drop down from there. Monitor. How are you handling physics? What should the target be here? Physics has to be, I mean, my monitor is 165. Okay, what's like 165 in milliseconds? Do I know what a millisecond is? I forgot what a millisecond is. Okay, so it has to be under 6. If I stay under 6, which it looks like it's hitting exactly that value, which means I would be losing some frames here and there. Possibly. I'm just trying to like really knock this thing around. Yeah, so it's actually not the limiting factor because it hasn't even passed 5 recently. So for the moment, it's doing well. All right. Velocities. Okay. So here's the big plan. Calculate an iterated motor velocity by running up and down leg chains. Odd iterations run end to root. Even iterations run root to end, so iteration 0 is even, so it'll be root to end. Maybe we should have wrote that. Whatever. Errors determine velocities. And velocities incur additional proportional errors in the next higher and lower joint angles. I think I had the full thing in my head of what this would do, but now I have to remember it. So basically, if I have errors determine velocities, and velocities incur additional proportional errors on the next higher and lower joint angles. Okay. So I think for joint data in joints, I think what I'll do is I'll do this. So I'll go and set it up so I can have a constant iterations value. And I think I was going to start with 3. So we go down the chain, up, and then back down the chain. And then I might just plug this into another function so I can drop out. So I'm just doing it on a single joint. I'm going to say if I mod 2 is 0, so this is even. Then I'm going to do even iterations run normally, so I can just run and then I'm going to have a solve joint motor, which all it needs to know is the joint. And then otherwise, I'm doing to -1, -1. Yeah, don't do that. I'm just gonna copy that. Yep. Why are you not happy about this? Already a for loop I. Ah. Okay. And now and I suppose I could follow how Jolt does it, where this returns a Boolean if it has made a change. And if I run through the whole list without making any changes, then I can stop, right? Like without making any changes. Yeah, I'll do that. And then I don't think or equals is an operator that they have. Maybe it is for Booleans. So we can break early. Maybe it's okay. So I don't care about that. And then all this will just tab out. Yeah, and then they don't have... Oh. Invalid operands for bool and bool assign mono. Yeah, this is just stupid. They have this for integers and they don't have it for booleans. But I can write it like this. Are you kidding? Or, wait a second, do I have to write that? Yeah, alright. The Godot sucks again. Godot sucks again. It was cool for a minute and now it sucks again because that operator, for some reason, only... That is a defined operator, but it only operates on integers and not booleans. Alright. But if I go through a whole iteration and I do nothing, then I can stop. I can stop. Although I have a feeling it's never going to do nothing. But I guess it's good to, it's probably smart to have that because sometimes it could do nothing. It could be such a small change that one iteration is enough and I don't have to do the other two. Alright. Do I have that? There we go. Target rotation, velocities. I calculate the velocities. And then I guess I can determine here if velocities is literally equal to vector 3, 0, then return false. Otherwise, I'm returning true. Velocity calculation improvements. So what I say is that the error determines the velocity, and velocities incur additional proportional errors on the next higher and lower joint angles. I probably gotta diagram it again, don't I? Oh, I've got a thing in like 6 minutes. Okay. I will be back. Very, very short break. Definitely less than a few minutes. It's gotta be. I'm back. All right. I've got to do... Oh, I need to change the task. I can do that. I've got to do something. Okay. I'm just gonna sit here for like a minute, or like 2 minutes. Do this. How do I move? Okay. I've got a name. Got a name to get. Few seconds. I kind of missed it, but maybe I'm okay. I really missed it, but it's going through. Did it go through? I got it. Okay. Great. There it is. All right. That was a special thing I had to do. It's done. Mission accomplished. All right. Back to this. Okay. Yeah, I gotta... All right. It's gotta be diagrammed. I had the whole thing in my head when I wrote it down. I was like, oh yeah, this is perfect. It's gonna be great. And I don't remember. Errors determine velocities. Velocities incur additional errors. I'm just gonna retrace my steps because I know roughly how I ran it, or how I came up with it. So I'm just gonna have big wall here. So that's a wall. And then I would have a joint, I guess, that just comes off like this. And then I would have a different colored joint that will go like this. And then I would have a target for this joint. Just gonna do like that. Alright, so now it's a ghost. This is a little loud. Okay. So this is a target. Okay, my middle mouse button just actually doesn't work anymore. How am I not selecting anything? Where? Oh, really? I had to like select the... I can't do that. I have to select the entire like fake box around it. Okay. That's dumb. Okay, but here's the idea. So I have an error angle. The error is this interior angle. So what happens is when I apply a velocity to this, what I'm really doing is splitting that target between this joint and the other joint. Now, this case, it might be... Okay. All I know for sure is that when I do this, I'm increasing the interior angle. Let me... Can I copy? Cool. I want to make this semi-transparent. So if I were to move this other one, right? Okay. Let's really zoom in. So I have an error angle, and the error is, I guess, this portion right here. So I don't know if it really matters to measure it, but I guess I can measure it. Although this tool is also useless. Alright, well, anyway. So what would happen is this would rotate and I would slap it up here, right? Like, that's the ideal. Right? So I determine the velocity and then I say, alright, now the velocity makes up for that error. Or the velocity is 0. Or actually, yeah. So it would have to be that the error is... The error is the difference in the angle. Okay, no. Let me think about this. Okay. Well, no matter what happens, I would have to calculate, I suppose, like the effective mass, or sort of, I have to do like some sort of calculation where I calculate what's going to happen. If these two joints are the same length, the same mass, which I think they're probably not, they're probably, this one's a bit longer, but what would happen is the velocity would account for that interior angle, but it would account for that interior angle like this. So if I take both of these and I were to rotate them. Okay, so it's, I mean, it's roughly correct. Here's what I'll do. I'll just do this. I'll fix this. Or, no. What I would have to do is I have to rotate this basically halfway there. So I guess like here is roughly halfway. And then this one takes on the other half. So, I'm just totally eyeballing it. But the result would roughly be to move the entire system like this. If I were to rotate it so that these were kind of aligned. Okay, I'm like totally messed it up. All right. I'm just going to rotate it like this. But then I know that whatever I've done this one by is actually secretly half. Which means I would basically end up with something that looks like this. So I have the target, the velocity has reached the interior target, but it's actually caused the opposite rotation to the other body. Half the rotation went into this body, the other half went into the other body. So now this one has an error. An error angle. So I think because I know these are two bodies, where for a given joint that I'm operating on, I'm changing the error of a body above and a body below. Well, I'm not really changing a body below. But I guess I could anticipate it like that. So I could kind of get ahead of the error and initially calculate it. Although maybe I don't even need to do that. Yeah. Basically, I'm spending a little bit of time on my side coming up with ideal velocities that the motor should have, so that when we get to the physics step, it can reach those velocities much faster. Right? Because basically what the physics step would do is it would come in here and see that this one has incurred some rotation, incurred a velocity, and so that it's going to try to correct that by bringing it up like this, which is then going to modify that interior angle. Right, so this one's like never really going to reach it because this one corrects, but this one's at the velocity it wanted to be at, that I told it to be at. So maybe it'll get kind of close, but not really. It's always going to be behind. So what I'm thinking is that I can do a little bit of initial stuff to say, all right, this one should not have a zero velocity. It should have a positive velocity to rotate counter to this one quickly. And this one needs to have this velocity so that it can reach its target quickly. So like before the physics server has even gone into the second iteration, it should already be reading velocities that are pretty good. Like maybe it would look more like this. Okay, so now the question is, what am I changing? I'm changing velocities. And how am I changing them? I'm changing them based on the error. So I think what I should do is I would calculate an error based on the current angle as well as the velocity of the motor at the same time. So that yeah, so the error is absolute, the error always stays how it is, but then I'm reading in that velocity and I'm saying, or I'm not really reading the velocity. If I give a velocity to the motor here, I know that the motor above it, I guess, and probably in the same sense the one below it. Well, no, this one shouldn't be changing the motor below it. This one should only be changing the motor of the joint above it because the joint is at this location. Rotating this body, actually, I guess it would, right? This one would, if there was a third joint here, it would mess with it. So I do have to go up one and down one. Okay. But yeah, basically, if I say this one should have a positive, a +2 velocity, what I would say is this one actually gets a +1 velocity, and this one gets a -1 velocity. So I'm thinking about plus. So plus would be clockwise. Okay, so I guess it would be the other way around. A plus would be counterclockwise. No. Yeah, a plus would be clockwise, so it has to rotate up. And this would incur a negative velocity, so this would rotate counterclockwise. And now I get in here and say, okay, well, this one's got a negative velocity and a 0 error, so I need to correct for that by changing the velocity to 0. Wait. No, because what should happen? This one should... It should have a... Basically, what I think is that when this one expands, this one should contract at the same time. Because it has to apply that force to resist the rotation that the joint above it is giving it. I can know what that is beforehand. So I can say this one needs a positive rotation, a positive velocity. But I haven't actually modified the velocity. So I think instead what that means is I need to modify the error of the angle so this one does get a positive velocity. Errors determine velocities, and velocities incur additional proportional errors. So I can calculate the error angle on all of these, right? I calculate the error angle, which is this. Or what I could do is I could go in there and I could say, I could just directly modify the angle and say that we've changed the angle, which would have the same effect. And then it would say, all right, so now I need to act against that. But I feel like that might be wrong. Okay, let me say this. Okay, what am I doing? I'm calculating a target velocity. I don't care what the velocity is now. I'm calculating what it... Okay, I don't care what the velocity was before. I'm calculating the velocity it needs to be now. Which means velocity is equal to some function of the error. Right? Maybe what I should do is say... And I guess the other thing is it actually does stop at the point where the angles change, or the axis changes. So if I'm looking at a joint above me and it has the same rotation axis, then I know I'm giving that, I'm putting some error into that one. Let me think about this. If I need to do painting, I guess. If I am rotating this guy this way, what does that mean for the other joints? I think it just means the other joints always rotate the other direction. So this joint would rotate the opposite way, like this, if there was a joint there, and this one also rotates the opposite way. Okay, so it's really simple. And the way that I know what those proportions are should be, I guess, the effective mass, because if this has a motor on it, yeah, I would calculate an effective mass and then I use that as the proportion. But the thing is, down here, this joint, I don't really... Going up feels right because this is a joint attached to this one. But this way feels weird because... I mean, I guess it's fine, right? The impulse, I think it just means that I take this. Okay, the reason it's pretty simple is because I just take this piece, I rotate it that way, I know what the error is. I take this piece, I rotate it that way, I know what the error is, right? But this one is weird because I take this piece, I rotate it that way, and this one I don't rotate. So this one doesn't... So the error would just be whatever this one rotated by, and assuming this one does not rotate with it. So the error incurred here would be the effective mass times this one's inverse mass. The error here would be... Is it just the other way? It's this one's mass. Times that interior angle. It's probably like that, right? Yeah, because what I'm looking for is this error is just whatever this one rotated by. That becomes this error. And this error is whatever this one rotated by. And that becomes this error. The interior error should drop to 0, or it would target 0. Because I've rotated both of them like this, right? They both rotated, they reached the angle. But this one rotated it, added error here, this one rotated it, added error there. Right, that's how it works. Okay, so I do apply above and below the joint, if they exist. And the way I would know the next joint is... How do I know the next joint? I could just store it when I'm like reading them in. Because I have to get the body of the other one, get its inertia tensor to know what I'm about to do to it, to know how much additional error I'm going to change. And I guess, yeah, I guess I can know for a fact that if I change the velocity of this one, my error goes away, but I pass on, like, I end up passing on error to the next ones. Does this even make sense? Because what if it's that I pass on the exact same error to the other ones, and then it never fixes? And they all just... Is that true? Okay. So I think then in that case, I need to keep track of a... Would that happen? Well, I suppose what it means is that the error disappears when I reach a point that I don't care anymore. So in this diagram, in this example, this error doesn't happen. So I pass on half of the error to this guy, or whatever the proportion is. If this was the main okay, and then this one, if this is the main creature body, which is significantly more massive, whatever velocity I apply to this guy is almost entirely going to be focused on that interior angle. So the error over this side doesn't even matter anymore. It actually just goes away. I could still pass it through to the main body and then say, I'm not going to do that. I'm not going to do that. I'm going to ignore that. The legs should be light enough relative to the main body that it's effectively a static object to them. So whenever this one rotates, it passes on only half of its error back down the chain. Okay, so yeah, it's like, I could think of it as being like some sort of sheet with air underneath it, and you're like pushing the air out the sides as the error. So you still push around the same amount of air, but eventually you reach a point where it just kind of goes away. Which, in this case, it goes away whenever it hits a static object, which would be like, it's a static object or there's no joint there, which is like at the end of the leg, or it hits the main body. And then it kind of just, the main body incurs that and says, sure, whatever, I'll take it. I'll take the error. Okay. Okay, so it does seem like it's pretty much just going to pass on the errors and not really get rid of them. But once we reach the top main body, the error kind of goes away. And then when I go back down, the error goes out the last joint. So this is probably where I maybe require at least one iteration. And it might be good to start in the other direction, going in reverse. Oh no, this is right, because this is root to end. So I start by going out, and then I come back up into the main body, and then we go out again. But it does not pass on. So once we hit the main body, I could have it still pass on using the main body and sort of calculating what the resulting error angle would be on all 5 other legs. I could calculate that. I don't know how to really access them at that point. I mean, I definitely could. I just can't think of it right now. Okay. So the velocity is some function of the error. When I create a velocity, I basically make the assumption that I've canceled the error at my joint, and I've passed on that proportional amount to my neighbor joints. Okay. So if I calculate I need no velocity, then I don't do anything. So the velocities here are just the difference in the angle is the velocity. So let's say I have 1 radian. I would want to travel at 1 radian per second, which means it would take me a second to reach that. I do want a maximum velocity. But you know what? I think that doesn't really... Yeah, I'm actually going to drop max velocity. I think that doesn't make any sense. I should just have a max... Okay. No. I'm going to have a max velocity. But it needs to be relative, I think, to... it needs to be more about the velocity of the end of the joint. So the joint is pinned to two bodies. It's more about getting the velocity of the end. So if this one's 1 radian per second, what does that mean the end of the leg is moving at? And I want to keep that at, I think, less than a meter per second. I don't think I want... Okay, but if the body can travel 3 meters per second, that means at any given moment, in reality, the end of the leg is traveling at least twice that speed. If we're doing step, 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 like half the time this leg is moving, half the time this leg is moving. But even then, it's actually less. It's like 40% of the time this leg is moving, 40% of the time this leg is moving, and the other 20% neither one is moving. Those percentages are probably too high. It's probably more like 48% either leg is moving, and then 4% of the time neither are moving. So at the minimum, the actual end of the leg is rotating more than double the main body's velocity. At least double. Usually more than double. So it probably doesn't make sense to do that, because then, yeah, I think it should just be what do I want to limit? It's more just about limiting the force, because force is what hurts. The whole concept behind this is that these robots are not actually meant to be killing people, so they were programmed well to not accelerate their legs so fast as to cause injury, which means accelerate, which means force, so they can't apply so much force that they can injure somebody by walking into them. Brazilian prisons are horrendous. Americans don't know how easy they have it. I think they do, because Americans will intentionally be arrested and jailed so they can stay in prison. I think they've got a really good idea. I mean, I guess I should just probably... So leg joint does have a max torque, but I do have an idea of a max velocity. So, what am I thinking of? When I think of like kinetic force, that's half mass times velocity squared. Did I even spell that right? Kinetic force. It's gonna tell me kinetic energy. I'm just gonna... Safe speed for robotic terms are defined in ISO collaborative robots. Cobots. What? Is this the thing? I'm looking for ISO. You're not really going to make me log in. Add to cart. CHF? What currency is that? Swiss francs. Dude. Dude. I don't think I need to pay for this. There's no way I actually have to pay for that. This is a PowerPoint. All right. I hope I never kill someone. Me too. The thing is, this doesn't make sense because they're talking about just talking about rotations in degrees per second. That doesn't make any sense. Also, these got to move faster than that. I'm pretty sure these need to move like way more than 100 degrees per second in order to move. I think these are supposed to be robots that are like an arm that's doing some fine motor thing. So it doesn't even need to move. I need like... I'm just going to search Boston Dynamics. I'm just going to tack that on there. Because there's no way their joints can't move that fast. Oh, hang on. Joint speeds and forced calculations. Where's the rest of the page? I saw an M. I saw an M. An M. I saw it. How does this happen? How does it save this sentence and then it's not here? It's not here. Safe. Forces for forces. All right, just give me the verifying I'm not a bot. What does this mean? Verify? hundreds of newtons. Okay. Is there a way, but that's also impact force, that's not kinetic energy. Is there a way to convert kinetic energy? There's it's not a thing. It's not a thing. It's not a thing. Quantitatively equivalent? Hmm. Okay. Okay. So I think what I do is I calculate a velocity of okay, hang on. I think the first thing that I should do, that I should really do, is make it so that this crawler can stand up on its own. Because right now, it's just too heavy. These are all like kilogram masses. So it's just too much. What's the name of the dog robot? I don't know. A 100 kilograms. Big dog is 100 kilograms. What the hell? It had a combustion engine. Okay. Spot. This is not the legs. I would like to know the legs. The battery is 5 kilograms. So subtract 5 kilograms. The total thing is, okay, 5.2, 33.8. I'm just going to do this. The whole thing is 28.6 kilograms. It has 4 legs. So if I divide that into 5 parts, so roughly each part is 5.72. So 5.72 kilograms. But I'm going to say the mass ratio of a leg to the main body is probably like 80-20. So if it's 80-20 and there are 4 legs, well, if it's 80-20, then that means this would be like 20% of this goes to the legs and 80% is the main body. But that doesn't make sense because I'm talking about a one leg to one thing. So if all parts are this, I guess what I would just do is I'll take 5.72 times 2. So then if this is 80/20, a single leg in total is 2.288 kilograms. So I do 2.288 times 4 plus then yeah, I did it wrong. How did I do it wrong? I know how I did it wrong. If it's 80/20 from body to leg, then that means it would be like 20% times 4. So what? Oh, weird. I should do the same calculation again. So this would be the mass of the body. So the body would have this mass. That doesn't make any sense. How am I thinking of this? All right. Total mass is equal to 28.6. So then total mass would be equal to body mass plus 4b plus 4l. Okay. So I know that B or I know that 1 is equal to 0.8b plus 0.2l. Does that make sense? No. I know that... Okay, this is where ratios get strange. Because it would actually be... Would it actually be 0.2 over 0.8, or is it 0.2 over 1? Which is just the same value. So if I say the ratio between a leg and the body is 80 to the body, 20 to the leg. So if I have a kilogram, I know that 80% of that is in the body, 20% of that is in the leg. Right, so 1 I guess, how do I set up so I have an equality between the body and the leg? Okay, I mean, I just know that it would be like this, right? So could I just substitute this as being gosh. What the hell? What? Okay, 0.8 over 0.2. A body piece is going to be 0.8 over 0.2. Is going to be 4 times the leg. Okay. Well, there's my solution. So, but how could I represent this as being... I'm going to guess I just know that this is an 80 to 20. Ah, right. I have the ratio. Okay. So I know that the ratio is 80 to 20, right? 80 to the body, 20 to the leg. So, I mean, that just means... You're alright, buddy. Does that just mean if a body is worth the mass of 4 legs, then my solution is already right here? I guess I just write... Why did it do that? That body is equal to 4 legs, right? That's the ratio. So body is equal to 4 legs. So in order to have this, I just know that the body is half of the mass, right? So I can just substitute for either one of these that I want. I'll substitute for legs. So it would just be 4L plus 4L. So 28.6 is equal to... Well, I guess what I'm looking for is to subtract... Wait, how would I do this? Hang on. What's the way you would substitute this? I mean, I guess I'm actually doing it right. So I'll just take 28.6 divided by 8 to get the mass of the leg. Okay. So that's the mass of a leg. And then I would actually divide this by 2 to get the mass of the body. So 14.3 plus 3.5557 times 4 should be the same as that. Okay, cool. All right. How can I calculate the amount of torque it should actually have? I'm just modifying the velocity directly, so it doesn't matter. I'm not applying it as a force. I was thinking about the main body rotating to face you. It just applies a velocity to itself, that's all it does. It uses infinite force. Or well, it still accelerates, but it uses an infinite amount of force to achieve the acceleration. Okay. So now what? So if I were to split this between the legs just by their volumes, I could round it down so, well, I think I honestly should probably round it up. So the main body is probably going to be 15 kilograms. And then the whole leg chain combined would be 4 kilograms. So that would be also 4 times 6 is just slightly over the main body mass. Okay, not just slightly. It's much more than the main body mass. So do I need to make them even lighter? Do I need to go for like a 90-10? Hey, that man, what are you making? I am trying to figure out the masses for this crawler body. So I've got the legs. I just want to have masses that make sense on the legs because the whole thing is going to be physically simulated. So I'm just going through that right now. I don't think most of the mass should be in the legs. That doesn't make sense to me. It should be mostly in the main body. So a 90 to 10 would be a 9 times. So that would be... that case, a body... Let me just round everything up. So I'm using 30. Make a script that would divide all the mass depending on how many legs it has. I could do that. That's probably what I'm going to do. But I at least need to know, like, have an idea, first of all. So 30 would be equal to... Well, actually, I guess in this case, I should just map out what I think the total mass should be. What was... So spot is that... Sure, I'll say 40. Make more creatures that can all have a similar mass body ratio. Yeah, I mean, it makes sense. Because what I'm thinking is I would just have a mass that I set on the character, and then I set a body to leg ratio, and then it would be able to divide the mass that I set among the body and all the legs. Rate my UI on a project I'm working on. If you can send like a screenshot link or something, sure. I don't know about rate, but I'll tell you if I think it looks good or not, or if I like it. So 40 would be this. I would say a ratio should be 90-10. Right? So then I know that body would be equal to ratio times leg. And body is equal to 9 legs. So then I can just substitute whatever I want. So I would just say, yeah, I'll just say 9 leg. This one's probably easier to do it. 6 legs. So that'd be 15 legs. 40 divided by 15 is a little bit less than 3. So then I would have 2 point that to disperse. How can I send a screenshot link? I mean, there's just like websites, I can't remember what the name of them are, where you can just upload an image and you get a link right away. So my project is also coded all in Python. Well, I mean, this is GDScript, which is like basically Python, but also not supposed to be. I just like to use Python as a calculator because I think it's better than calculator applications. Calculator apps tend to suck, I think. Okay, so that's a single leg, so then I can just do I can just write that to get the body mass. So body mass would be 24. And then okay, yeah. So that puts a little bit more than half of the mass in the main body and the rest in the legs, which still feels too much, I guess. Is you check the website? What? What are you talking about? We're talking about virus scans. Hey Yelia. Yeah, since I know what the calculation will be, I think I can actually go and just write it in there. So the crawler bot will ready, it will load the number of legs, so it gets the leg count and then it returns. Okay, good. So my idea is I have the mass down here, and I would have percentage of total legs necessary to lift the body. Is this Godot engine? Yes. Godot is not paid. It is free and open source. Wait, right? Yeah, it's MIT. This guy's the reason all our games are unoptimized. And the guy said Unreal. Yeah, then it must be Unreal Engine. Okay, so I get the leg count, and that's what I need. That's what I care about. I just don't know where to put this. I think I'll just probably put it. This is like parameter section, but then I have something called a leg mass ratio. Maybe I should just rename this to leg lift ratio. Yeah, I'm gonna change it to leg lift ratio. And then this mass needs to be never trust streamers. Love Godot engine. Yeah, it's pretty good. I also think it kind of sucks sometimes. On any given day, I'll be a big hater, and then the next day I'll be really happy. Not good for 3D. I think it's fine for 3D. I think it's going in the wrong direction for 3D. It's kind of trying to be Unreal with global illumination, which I think is just never, ever gonna work. And it's a terrible idea. No one should ever use it. But it's still got some pretty good things. What am I looking for? I've renamed it to body leg lift ratio. And then I need to hit save. And then I need to click 0.4. Okay. Do I have... Did I just make a file called P? Okay. Okay, it only exists in there. Good. Think about giving these bots AI minds so they can bait them operate on their own. I will be doing that, yes. Right now, I just need them to... I need them to even be able to move in the first place. Okay, so I've got that. Now I want to have a body leg mass ratio. Leg parameters being prefixed by body is kind of silly. Alright, that's great. I'm not going to use it though. I think it's as good for 3D as any other game engine is. Where am I going to put this? I should put it here. But now I'm like regretting my name choices. But this is also relative to that. But that's going to change the mass of the main body. So what should I... Also need to make sure it doesn't run there. Alright. I think what I do is I have like a total mass parameter up here. And that total mass parameter will determine what the mass of each leg body and the main body should be. And it will use the volumes of the shapes to share the mass. That's probably what I should do. Or maybe I should use the bounding box. I can't use that. I could use that. I would just reset the transform. No, I don't know how I would do that. Does a shape 3D... have anything about capsule shape? Nothing. I just don't like how everything renders and appears. Part of making a 3D game is doing shaders. I feel like you could say the exact same thing about I don't like how 2D games look because of how everything renders and appears. Like you're supposed to spend time to make it look nice. There's nothing stopping Godot from looking as good as any other game. From looking as good as the best looking game ever. There's nothing stopping it. They should make it look good in Unreal. I would disagree. I think it's harder to make things look good in Unreal. It's much more difficult to achieve something that looks good in Unreal. Because Unreal stacks on a lot of stuff you have to turn off. And then you have to be very, very mindful of the entire render pipeline. In Godot, I can just make a post-process shader. And I can be sure that it's not... I don't have to think about anything weird. What's the other shape kind? Collision shape? Make convex from siblings? What? That's cool. I didn't know that. But how would I even use that? How would I use that? I can't use that. Interesting. Everyone has their own preference. I think there's no preference there. I think it's just reasonable. That Unreal Engine is difficult to make look good because there's defaults you have to turn off. Unreal Engine's Godot Engine's the other way around. They have very normal defaults and everything is up to you. Dog. Okay. I actually gotta get food, so I'll be back. I'm back. I forgot to turn off the music. Okay. I've got food. I'm gonna eat. What the? That is a... So for Unreal Engine, it does... It does a lot of stuff to make it easy to just, like, basically turn it into a level editor. But then I don't think it actually has any leg up on Godot. Because Godot is like the exact same way. You could say you like blueprint scripting and Godot doesn't have that, and that's fine. I think if you're actually making a serious game, though, you should not use blueprints at all. Or reserve them only for simple things like a door opening thing. Or like a single object that's not going to be... that has to be activated by player input. And it's just going to run like one line of stuff and then it's done. I like that Godot doesn't have that because I have to be mindful of what I'm doing all the time. I'm not going to accidentally leave a blueprint that's just spinning forever and like sucking up 5 FPS throughout the entire game because I just forgot that I forgot there was some debug thing and I should have had it deactivated. Also, yeah, I'm a really big fan. Okay, so the main thing that got me to even try Godot in the first place was because I was going to make a game with a friend, and I didn't want to use Unreal because we'd be working at the same time. And from my experience with Unreal, it could have changed by now, or there might be some stuff to make this better that exists. But basically, if you're going to work on the same level, one person, like, a day can, like, have full ownership of the level. And that's how it works. If I want to change a script, or not even if I want to change a script, if I want to go in here, what I'm trying to do, I want to go in here and I want to add some bone targets or change something here, the entire crawler bot is now reserved for me. If my friend were to like go in a crawler bot and just change max speed to 2, and that's all that they did, but I came in here and I changed this body's mass to 2, Unreal Engine would basically be impossible to work with like that. Because in Godot, these are text resources. So I can use Git, and we can actually combine our changes on top of each other. Unreal Engine, you can't do that because the whole thing is its own binary object. So you would have to use some tool to merge them, or something other than whatever Unreal Engine does by default. The default for Godot is that everything is text-based, so I can even, like, if I hit save, and I go here. I'll just go down to where the first change is. So max speed, 1 line change. And then down here, I think I changed one that's probably been added, so it's not even going to show up, but that would be the idea. We would both have 1 line change, and we would be able to commit our changes together at the same time. And we don't have to ask each other, hey, are you modifying Crawlerbot right now? And I would say, yes, I am. And he's like, oh, okay, well, great. I just changed it too, and now we need to merge our commits, so we need to figure out how we can do that. I didn't want to deal with that. So I saw that Godot had text resources, and that was all I needed to see. And when you build the game, they don't have to stay as text resources. They can become binary resources, so they still save on... You still have the space saving aspect of it, where your resulting game is all going to be in binary form. But when you're working on it, it's all in text form. And then you can even change it midway. If I decide at some point that the player character is locked in, and I never want to change it again, I can change it to a binary format. And that would be like a real commitment. It'll forever be smaller, so whenever I'm doing... If anyone else was to work on it with me, they would have to download this stuff. And then it was also, I didn't care what programming language it would require, as long as it had something. This one is like Python. So it's really easy to quickly write. And then whenever I want, I can turn it. I mean, I wouldn't turn it. I would be able to rewrite it in C++. And that can just directly integrate with the engine. Also this, I've never seen this before. I gotta find it. No. Wait, I was already at the right place. Script, post-process. So I was writing my own auto exposure shader, and you just get like direct access to like graphics APIs. So I don't have to write this in like C# or C++ and make sure I have everything the right type, and I'm doing casting, I'm doing references, and I'm doing pointers and memory. None of that. I mean, there's a little bit, but it's really easy. There's just like a shutdown or whatever, and I would just call free RID or whatever the method is. Where is it? Because I have to delete these. Oh, I have the not here. Okay. Well, this is my own terrible programming. I shouldn't write like that. I just see what equals and return. I'm like, okay, so it's not here. I forgot that I missed the not keyword. Yeah, there's a little bit, but it's really not much. You just have to call that method and that's it. Normally, I would have to like do a crazy, like half the job would just be memory management, honestly. And then I would have to figure out how to call these methods with the right values. Which, at least in this like Python-like script, it's a lot easier to do. Because I don't have to think about a lot of what I'm doing. I mean, also, it just seems like their APIs are just good in the first place. I have not done too much with, like, DirectX or Vulkan. But I know that they have very large APIs. And you basically have to learn everything about it before you can even write a line of code. It's like borderline impossible to even just learn by using it. You have to learn by understanding the whole thing, and then you get to start using it. And then you're going to be wrong almost every time. You're just going to have a black screen, you're not going to know why. This like front-facing API is really good. Dog is looking over my shoulder. Stop. You're way too close. Yep. I'll be back. I'm back. Okay. So I want this to have... Right, I was looking to see if I could determine like a volume somehow. Ideally I would use the shapes as the volume. But then I have to do like calculations for that. And that doesn't sound very cool. And then it falls apart if I use multiple shapes, because then they could intersect and then my volume's wrong. I could just use bone lengths, because they are assigned to individual bones. So I could use the length of the bone and just treat them all as having some like specific size. Or I could just use lengths purely. Pure lengths would be fine too. Yeah, because whatever I say there, then the length, something with twice the length should weigh. I think lengths are fine. Technically, volume would matter if any of them, let's say it was a meter by 1 meter, that's 1 cubic meter. 1 by 1 by 2 would then be 2. But if one of the legs was actually like 2 by 2 meters and then it was half a meter, that would be 2 cubic meters compared to the 1 by 1 by 1, which would come out as 1. So it'd be shorter, but twice the weight, twice the mass. I'll just use bone lengths. That makes it easy. I don't have to worry about shapes or anything like that. The physical skeleton will not load them yet, but I can use the IK to read. Alright, what should this parameter be? Yeah, I need a total mass up here. I'll default 30. I feel like it's a fine default. But then, of course, this one will actually be 40 total mass. Unfortunately for everyone else's argument, Unreal is simply... Okay. All I know is I tried putting a house into Unreal Engine. That's literally all it was. It was a basic character controller and a house. And my computer was crashing with only the interior wall faces. I didn't do any... I feel like I didn't do anything crazy. I turned on the sunlight, and every now and then it would crash. And I was like, wow, I have literally like 8 interior faces out of my house that has like 1,000 faces. And Unreal Engine is running out of video memory. I feel like something is wrong there. true experience. I literally like made a file, made a project. I put in a sunlight. I turn on the clouds. I loaded up my interior walls. Well, I was trying to figure out the lighting. I loaded the whole mesh at once. The whole mesh was fine. It was lit terribly. So then I tried to load each individual room, and it looked better. And then I put textures on it, and then I started getting started crashing. That's how Unity felt to me. Well, I never had Unity crash, but I also made like the basic FPS shooter tutorial. So that didn't even get into the like lighting or rendering stuff or custom meshes. I don't know what I could have done wrong. Also, the whole time, like, my computer was just dying as well. just turning on the light was like, I couldn't really stay at 60 FPS with the light on. And the only thing in the world was a flat floor plane and the interior faces of one room. Not crash with tweak on a change 2 lines of code. Needed to recalibrate. Of Godot, how user friendly it is. I like the scripting. I think the scripting is cool. I think it's nice that I can stay in the engine and write code. And for the most part, crashes have been my own cause. Because I do something ridiculous with the graphics API, like I have a while loop or something. I had to use it to develop VR chat. Develop for VR chat? What does that mean? Oh, never mind. No, I understand. Right, VR chat runs on Unity, and you like create characters in Unity, and then you put them in VR chat. Okay, so I get this. So what I'm going to do is I'm going to read in. I'm just going to make a method. Update. Update body masses. Setting this value should also call body masses. I don't like S's in there. I'll just call it update body mass. I should probably put it down here. And then I need the ratio, so I have the total mass, and then I have the should I put it in leg parameters? I think it fits with that, so I'll do that. I wonder how I should consider the force needed to lift the body based on its mass. Because I have these values, and these values are relative to the mass, so I can tweak the mass of the body without changing how the springs act. Or at least in theory I would be able to. But if I change the leg mass ratio, then that means less of the mass is on the center body and more of it is on the legs. And some of that mass needs to actually be lifted. I think especially the first joint. I have to account for 100% of the first joint to lift it. Maybe that's what I say. Maybe I add up all the masses of the leg parts and then use... Or I just base it on total mass. And then I can just tweak these if I think they need to be tweaked. Let's ride my bike. Have fun, Adeline. Okay. Yeah, I think it's just what I should do. I should probably just use total mass. It's hiding it from me. It's in one of these. Oh wait, no, it is, no, it is here. Yeah, okay. Alright, well, okay, just where do I use mass? Because I know that needs to be replaced with... Yeah, there should be total mass. State inverse mass. Okay. So it should not be that. Dog is barking. This is divided by inverse mass, which is the same as multiplying by mass. Okay. Total mass on all of these. Leg masses. That's oddly familiar code. Why? Why is that duplicated? Interesting. Yeah, I think this is probably just the safe option. Because I'm going to distribute this mass along the entire body. And so a leg should technically be able to support itself and the body. So I use total mass values instead of the mass of just the main body. However, center of mass does have something here where it might actually be wrong. I'm mostly concerned with state center of mass. Yeah, because the center of mass is not actually correct here. The center of mass is moving constantly. I mean, I can calculate it every frame. That might be a good idea. To calculate the center of mass given the current positions of everything. But I think that somewhere around here... Yeah, the body plane. I could do this. Here's an idea. Every individual joint could have no gravity effect to it. And then the main body would now I'm really concerned. I can't immediately convince myself that it doesn't matter. That the center of mass is not technically different for the entire body. Because it, in certain orientations, it may not be able to stabilize itself. Because its center of mass is lower than it thinks it is. Especially for this. Because this is specifically calculating... This is specifically projecting stuff to a center of mass plane that is not the center of mass. So I may... But also depends on like which body is being acted on, right? These are the legs pushing the central body. So if they're going to push the central body to avoid rotating it, and if the motors are going to fix themselves to the IK, and I would have springs, so they shouldn't be rigidly colliding with the ground. I think that's actually a thing I should probably do right now. Okay. It might be fine. I need to make it so these shapes are not hitting the ground like this. This needs to not be happening. These should all be shared, so when I move it, they should all move. Yep. But they're going to move wrong. So let me think about where I would want this to be. Let me duplicate this and let's say 20 centimeters. This seems fine. Although maybe they should be really short or like close to the ground, but then have very, very strong springs. So maybe 10 centimeters. I'll say 10. So what is the value right now? Five. What if I just did 5? maybe I'm okay with that. 0.75 and 1.5. Okay. So now I need all the tarsus joints. Make them all 0.75. All right. So I'll leave this here as just the rigid portion. Okay. So then hopefully the idea is the legs may contain, may drop the center of mass. They shouldn't have, hopefully they don't have so much of a change that it affects it's self-balancing, which I mean, I guess technically, yeah. If I'm using this to like position the body away from the ground, then this should be fine because it's trying to minimize the rotation of the main body. It doesn't care about the legs. The legs are going to do their best to stay in position. And this is basically going to balance its orientation in the field of gravity and the other sections are responsible for slowing it down. So if the legs are applying angular rotation, this has a correction for that. Okay. I think I'm fine. I hope. All right. Update body mass. Okay, so now I need this ratio. I need to figure out what I want to put. Do I put it in leg parameters? I feel like I'm going to put in leg parameters. I want it as a ratio of like 10:1, 9:1, 8:1 kind of thing. So yeah, it's basically the question of how many legs does it take, or this value, this number, or this number. How many legs equals the mass of the main body? So I would type in the ratio as like an integer, or not an integer, but a float. The higher the value, the more the main body has. The lower the value, the more the legs have. So I'm also going to start it off at 1. I feel like you shouldn't go much lower than that. In fact, I think it should probably start at 4. I don't think you want to stay lower than 4. So I can allow it to 16, and then I can give those increments. All right, I'll leave it at 1. And I'll start it as 5-1. Yeah, should be greater than the total number of legs. Let me see this. When greater than the total number of legs, more than 50% of the mass of the... Yeah. And then up here, I'm going to write down... This is used with the leg mass ratio. Do I actually have these set to... They should all be at 1 gravity scale, right? Yeah. Okay, so I got the values that I need. Leg mass ratio, I want this to probably be like 9. Update body mass. So essentially what I'm doing is I want to calculate the total mass. First I can start with just the mass of the body. So I would have the equation total mass is equal to body plus the number of legs and then I have an arbitrary ratio. So I know that I want to go this. So I've been using this to calculate the mass of an individual leg. I want to calculate the mass of the whole body. So then I basically still have ratio times L. I can simplify this to get this in terms of L. Because basically I want to take the NL and... Yeah. So then what I would do is I would say, to get L by itself, L would be equal to body divided by the ratio. So total mass is equal to body plus N times body over ratio. So then I would have this would be like saying, what is this like saying? I can divide B out of this. So I have B times 1 plus N over the ratio. And then I would do this. So body is going to be total mass divided by 1 plus N over the ratio. Then a leg would be if body is equal to ratio times L, then it would just be ratio times L plus NL. I can extract L from that, which would just be ratio plus N. And then leg would be equal to total mass over ratio plus N. That is the math. Gotta head off, but good luck. Hope it works out. Thanks. Yeah. Thanks for hanging out too. Okay. So using my values above, this should be 40 divided by 1 plus 6 over 9. I don't know why I wrote that like that. I meant to do divide. Good. Successful stream. I appreciate that. Those kind words. Thank you. All right, so that calculates the body and then an individual leg. Be this over the ratio plus N. Great. Math. Is this algebra? This is what algebra is? What's... I don't know. All right. Do I have anything common here? I don't. One plus leg. leg size. I guess that's the common thing. This would be body mass is the total mass divided by 1 plus leg count over the ratio. Cool. I guess I could calculate. No, I don't know if that works like that. Okay. Total mass over ratio plus count. Yeah. Should I show my work for that? I'm going to copy this whole thing. I'm going to copy this. Did that copy? I'm sure it did. Great. I think this does have to be indented though, because otherwise it's going to complain. So that calculates those. Now I would just do mass is equal to body mass. That's really simple. And then I need to distribute leg mass across every individual rigid body. So I need to work through IK chains. I need to work through the IK chains, calculate bone lengths of each chain. Normalize it. Yeah, I would normalize it. So if I had like a 1 and a 2, the result would be 1/3 and 2/3. And I would distribute leg mass to those bodies in that way. So, yeah. I need to have a mapping that goes from a bone ID to its multiplier. For each setting, I can calculate the length of the chain, and then I don't really need to do that. Yeah, because when I have the ID, then I just look for the modifier target, the modifier bone target that has that bone, and then I can set that. Okay. I wonder if I should have a slider. The slider would basically say, with an input of 0, yeah, the slider would be an input of 0. It would distribute the mass equally based on bone length. With a value of 1, it would distribute all of the mass into the first bone in the chain. A value of 0.5 would then do what? I can't really do that, actually, because I need those extra joints to have mass, otherwise they will struggle to apply forces up the joint chain. And if that happens, then I would need to have very high step numbers to pass that velocity along. Would I? I don't know. Would I? Maybe I wouldn't. Nah, I'm not going to do that. I'm just going to do it based on bone length. And yeah, I'm thinking I probably will just merge those first 2 bones so that I only have 2 joints doing X rotation, and one of them will be doing Z rotation instead of doing 1Z and 3X. Should I just do that now? I kind of want to. I kind of want to just do that now. That would make everything nicer. Okay. I'm going to try it with the 4 joints, but yeah, I'm sure that I'm just going to not like it and then have to do that. Okay. For setting in range, leg IK setting count. Okay. Now what I'm going to do is I'm going to get a total length variable setup. I'm going to go for bone ID in range leg IK get bone count joint count get joint count setting. So the length of this bone is defined as its origin. Should just be its origin, because its origin will be relative to the parent. Yep. I have to calculate lengths twice, but that's not a big deal to me. Right? Now I do it again. And once I have the length, I can apply them. So in order to do this, I have to find the modifier bone target that targets this bone, and then get... I'll just do this. I don't need to get this every time, so I'll just get this at the top. A recursive true, untrue. Yep. Then I'm going to use search. Okay, in this case, I'm actually going to do it. So I don't like this, but I'm going to do it. For body and rigid bodies. Body parent should be a modifier bone target 3D. This should not have moved them around yet. But this will be a problem if this happens, so I'll do an error. That'll just be a return. Okay, bone. Body parent, bone, the body. Okay, good. Now I can look up by that and access the body directly. So then I run through them again, and at the total length of the chain, now what I do is I just take that bone length over the total length, multiply that by the leg mass, and that's the mass of this bone. And then I'm going to say this is also a problem. Bone, I think skeleton can obtain the bone name. Yeah, get bone name. Also a problem, so stop right away. And then body mass will be equal to leg mass times skeleton get bone rest. And there it is. So now, if I were to change this value, bone lower section does not have an associated... Huh? What? Why would that happen? Bone lower section. Why are you reading... Oh. That's not the bone ID. That's the joint. $40. Front left tarsus leaf does not. -1. -1. So the main body has a mass of 18 kilograms. Does that make sense? I have a leg mass ratio of 9. Also, the leg mass ratio should call this update 2. I have a leg mass ratio of 9. And I typed in 30. So that means I expect to see 30 over 1 plus 6 over 9. 18 precisely. Very cool. Now, I don't, well, I'll calculate it. So 30 over ratio plus n, so it's just be 9 plus 6. So a total mass of 2. So if I run through each of these, none of these should be more than 2, but all together they will sum up to 2. So the front left leg. This one. A mass of 371 kilograms. It's probably going to add up a little bit less than 2, or maybe a little bit more for rounding, or exactly 116. So does this make sense? Does this immediately make sense to me? It does not immediately make sense to me. Why does this first one have so much more mass? So I'm already wrong. This one should have more mass because it's a longer bone. Oh, no, it's the length, it's the origin of its... It's the origin of the next... Of the next one of the chain. Okay, so that's my mistake. It should be get joint bone joint plus 1. Joint plus 1. Because we want to read the origin of the next joint, because that's the length of this bone. Okay. Now I'm going to type in... I'm just going to do 40 and then back to 30. So this one stayed at 18. And now this one still has a mass of 0.371. Oh, I didn't hit save? I didn't hit save. $20, $30. .371. I don't believe you. Reload the scene. I think I'm being lied to. I am being lied to. There's an error. Front left tarsus leaf does not have... Are you kidding me? Oh, okay. The body is the one above it. Then bone is that one. So this will be bone for body. Bone for body. And this is going to be bone for length. Okay. Now if I go 20, and then 30, and then 30. All right, this is making more sense. 0.057. .177. 0.565. And 1.2. Wow, nice. It all rounded, and that's actually perfect. Okay. Sweet. And then I'm sure that worked on all of them. I will compare all the femurs. 177. 177. 177. Okay. I like it. It is calculating correctly. I will run now and I will see what happens. And then it breaks. Base object of type nil. Leg IK has not been set yet. The thing is, this is going to run twice. I want this to run only during the ready. So I'm going to say if legs is empty, I ignore this method. Very silly. Okay. And the whole thing is still hidden. So now I want to run into it and see. What? I shift clicked and it just didn't do the shift click. Okay, what do we think about this? Interesting. All right, cool. It looks like its legs are really light. Its legs are really light. Okay. All right. And I think I want to have a readout here just as like a value that is only for visualization. So this will be an export. None. No hint string, and then editor. I can't call it leg mass. So I'll say, let's do like underscore. It's just because somewhere down here I use leg mass as like an actual variable. This. And I don't want to change these. But I guess it is... Wait a second, is this... I'll call it single leg mass. Editor and read only. There we go. So now it shows up and I can look at it. Okay. If I were to reload the scene, it would tell me. And then if I were to say 40 kilograms, and if I were to go 8. Nice. Okay. So I'd even do that. I might do that this mass is 22.857, and then I would do 2.857 times 6. So then I could see the leg total is that. And then I think maybe right beneath leg. Leg mass ratio. I was thinking if I want to print that out too. So I can see the share. This is probably fine. Let's try this. So there's a lot of this Y rotation. Do I have a mistake there? Is that wrong? That should be wrong. Um, yeah, I don't think that should be happening. But it looks like every leg is doing that. That is a problem. Let me try to print out. Yeah, let me get this angle. And yeah, who is rotating on the Y? There's an instant Y rotation. Nobody should have a Y rotation. Right? Nobody should have a Y rotation. Um, why is that terrible? How can I just get the rotation around? Okay, wait a second. I've got an idea now. Make to red 1. Okay, someone just rotated. It was more than a degree. Joint data is for joint. This one, which is reading a really high velocity, in my opinion. That's really high. That is just barely more than a degree. And that is its local rotation. Well, that's its error rotation. That's from where it wants to be. It wants to rotate a degree on the y-axis. How does it do this? Let me double check. This should tell me changing that setting does nothing. Good. It should also be loading in the angles too. I haven't actually tested that yet. It should have loaded in the angles. So I should see that this joint has a... Okay. And then it should be turned on. This should be turned on. So I'm going to enable that so it turns on. Because I think what might be happening is it might be like rotating all the way around and then the motor can't even get it back, kind of thing. So I'll just make sure these are all turned on in the code. They should also turn on anyway. But here, I need to specifically turn it on. Angular, this is set flag. Angular limit. Okay. Is this every one of these? Oh, this is running 3 times. Okay, hang on. Let me just change this to 1. So I'm not running it 3 times every frame. This is not actually doing anything right now. Well, it is doing something. It's just not... also not doing it. Front to left. .19. Front to left. Again. Another one is at 0.19. No, it's still the front to left. Yeah, that's pretty annoying. Oh, I might have made, yeah, I've made like an error here. So if it was, add an equation here to calculate this. It's the stabilization factor relative to the number of iterations should be lower, depending on how many iterations you have, to make use of those iterations. Because otherwise it's just going to like keep feeding back and not really doing anything better. It's going to take longer to get there. So it was that the result of 10, or like 0.2 to the power of 10 would be something. And then I want to get the same value, but to the power of something else. So it would be I guess is it like this? And if I were to do 11, that's not right, because it should be not like this. I think it's probably like 1 minus 0.8 to the power of 10 over 10, and then this would be, no, this number should be getting lower. So it'd be like this. No, because I know that 1.18 would be the value. Okay. I know that 0.2 to the power of 10 should be equivalent to some x to the power of y. Should be equivalent to x to the power of anything else. There's a log here. There's something like really simple where I just have to like take this power and raise it to some division, I think. I'm not. I already did it before. I don't want to do it again. Did I use Wolfram Alpha? Can I type the L? Solve. Okay, so it would be x is equal to 0.2 to the power of 10 over the new value. Okay. No. No. No, it's not right. Because I'm pretty sure I determined that 16 should be 0.18. I mean, okay, it's probably just meant to be like 1 minus. But then they can't be right because I still have the wrong values. Yeah, about 0.18 from 16 to 10. No. This. Yeah, 10. So wait, have I just been wrong about it? I should have had 0.13 instead? Okay. You know what? I don't know. I'm not sure. I'll just stick with this. I'll see what this does. It still twists and then still twists. And then it's just getting worse and worse. And then other ones are getting worse too. How was 500 not enough to twist it? How is it even rotating? There. Okay, I'll just not do that. Here's what I'm gonna do. I'm gonna turn off. Turn that off. They were not torquing like this before. They really weren't. And I find that to be really, really annoying that it's happening. It is so much less when I do that. It's just gonna slide, that's fine. Yeah. Wow. Why? It can't do anything. It can't even stay upright. How? How is that possible? I need like 80 iterations to make it even, to make it not go limp. So sad. What's gone wrong here? All right, it cannot handle the extra joint. The problem is, I think this may be simply due to the fact that it has the one axis of freedom just may not even be enough anyway. It's very possible that, you know what, let me even say this. Let me say don't do anything. Let me just say return. Let me make iteration 0. Let me have it not do any calculation on motors. So there's nothing it's doing. Yeah. What would I have to go to? I mean, this is probably like mostly position steps. But I have to be at 40 before it can even... I have to be at 50 before it even stops wobbling. And I mean, I think this should probably also just be lower. I think I've seen that these have better solutions. What would 50 have to be? 0.04? So I have to be at 50 before it even stays stable. And then I probably have to go up past 60 before it... I'll just give it up 0.4. Before it could probably stay rigid. Yeah, I mean, they're all gone. All the legs are gone. Alright, so this basically just means I really can't have this many joints. This is too many joints. Yeah, legs on the other side of the body are flopping around. It's crazy how quickly that just becomes unstable because of this. And that wasn't happening with 3 joints. Okay. All right. I've got to drop it down a joint. So yeah, I'll just have to remap all of them. You know what? I am curious about something. I think that I would like to be able to set a higher stabilization factor for position steps for certain joints. That would be nice. Because all those joints, I would kind of like them to just solve for like half of their position constraint every time. I think that would be nice. That could be nice. Yeah, I think I can close this. Okay. I feel like I saw that this might have been possible. Where I can set an in. Or like it takes in that factor. And I'd be able to, I could actually change that, I think. Actually, there's something weird. I'm not seeing it here. Hello. You know anything about CPUs? They do math. That's what I know about CPUs. Position takes that. Wait. I don't know. Let me try it. Let me try. Let me see. I know there's a point when it definitely becomes unstable. You're doing too much. But how high can I go? Because it looks like that only applies for position. It even tells me position error. Okay, so what about that? What do you think about that? You still fall over. I mean, it's, you know, it's something though. It's probably still unstable. Can I just increase it? It looks like it's adding force. So that's too high. 0.8 is too high. Like there's like I can't. It's just not possible. Yeah, it's not possible. What if I did something crazy here? I were to let these have a very high share to 5 nodes, updated 5 nodes. Yeah, that's right. Did I say 5,000? 10,000. What if I let these have a lot of... Well, this is velocity. This doesn't even do position anyway. But I'm sure there's only two I would even have to change. Yeah, I mean, it's a velocity thing. It has no concept of that. In position steps. What if I did less position steps? What if I did have less? Okay, here's my idea. I'm trying to see if it's something to do with the fact that just how these angles are. Just the way the angles are. Not that. Here. keep the Z1 where it is. Okay, no, it didn't. Nope. It did not care. I mean, it does seem to be these two joints are just having the worst time. Those two joints can't do it. What if they had more mass? Or the rotations just look the exact same. What if they had more mass? Why is it so shaky? Okay. All right. I think I've tried everything. I've tried leaving those as very hard limits. I've tried increasing the position steps slightly. It's not helping. At what point would it help? That's crazy how I saw no difference between 20 and 40. What? Do I really have to do this? 0.06. Am I sure it saved that? Because by this point it was fine. What? Velocity. It is velocity. But I mean, this is just too high, right? Like, what, I have to have 100 velocity steps? And it's still going to... They're still going to wobble anyway. I'm going to guess at this point, if I were to turn this up a bit, this would... That'll be helpful. I think this is probably like 06. Yeah, I mean, I can't do that. I guess my worry is that this is just a case where, I mean, I guess I see it now that velocity and position steps are actually happening together. At least both of them being higher are helping. But that's also just way too high at that point. That's way too high. And I know that it was roughly pretty rigid when it only had to move on the x-axis. My thinking is that because I have a z-axis rotation in there, that could be driving most of it, most of the issue. And dropping it back down to 3 joints may not solve that. Okay. I mean, I guess I have to find out. I'm burning daylight, right? I need to find out. So I'm going to go into Blender, open that up, adjust the joint so the bone is now, I have 1 straight bone for the z-axis, and then I have 2 for x-axis. I guess I just didn't think. I really was kind of thinking that it wouldn't. Adding the 6 extra joints wouldn't actually mean that I have to go from 16 steps up to like 100 of each. I didn't think that would happen. And because it did happen, I'm sort of extra worried that removing a joint might not do anything, because it may just be the way the joints move, or the way the axes are restricted, and that's it. Because I feel like that stopped happening when I made the first joint able to rotate on the Z and the X. When it was able to do that, that's when I was like, oh, look, now I only need 16 steps. But that could have also just been because I only had 3 joints, but I was always working with 3 joints. Well, I guess it was terrible because I had a bunch of motors and springs, and then I just went to hard limits, and I increased the position steps and the velocity steps. This isn't even... It's not even in recent anymore. Yeah. What is happening? Alright. Quit. Try that again. I would like to be able to use my middle mouse button. What? What is happening? Why? 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 I don't even want to think about why. I don't even want to think about why. Blender. Navigation. Are we serious? I'm gonna explode. I just updated. This was like an update. Okay, I'm just gonna roll. Just roll Blender back. Just roll back, please. I don't know what this update did, but that's just crazy. I literally can't. I need to be able to do that. That's gotta just be a bug. But also that means this version has been out for that long and it's been like that. Or I'm gonna roll it back and when I launch it, that's still gonna be the case. And then I'm gonna be really upset. Why? Why? Okay, you know what I think it is? I think it's my keyboard. It's not the keyboard. It's the mouse. It's not the mouse. Oh. Godot? Godot is like just perfectly normal. It's just Blender. Linux. It's gotta be a Linux problem, right? Could it be Steam? It could be Steam. It could be Steam. Steam could be the culprit. There's nothing recent about this. I just want to get some real results. That's not... ...2 years ago. I haven't done anything. I've done nothing. I've done nothing. I've done nothing. I haven't done anything. It's just suddenly broken. It's literally just suddenly broken. Like, what the hell is that? It's like it's like my mouse sensitivity drops whenever I'm middle clicking for some reason. I'm in my mouse with alt to left mouse. What could it be? What could it be? Why? Why? All right, you know what? Literally whatever. Okay. I want these to be ordered in a better way. Because right now I feel like they have a weird order. Maybe they don't actually have a weird order. It's left, right, left, right, left, right the whole way through. Okay. Edit mode. So I'm looking for is probably just to if I join would it be like dissolve? That was way too many. That's just way too many. Is that way too many? Time to rotate really slowly. That is just too many. Why is it deleting? Also, I want it to go in the other way. No, no, no. All right, that's better. Okay, so I click here and I do dissolve. Cool. Now I remember something that I did here, which was maybe silly, maybe not, I don't know, where I would it's so slow. Like, what is this? Why? I don't know, is this real? Why would it, yeah. Why would this happen now? $10 months ago. Bro. What? So is it because if I make this not run X11? I don't even know. I have no idea what I'm doing. I have no clue what X11, wait, I don't know what these are. I don't know what these do. It's not. It says X Wayland 0. But do I want it to do that? Do I want it to X Wayland? I don't know. Okay. It's not my keyboard, it's not my mouse. It is Blender. It is Blender. And I can't, it's not a version of Blender. This is caused by my specific setup somehow. My specific configuration, which is like, what is this? Some people are just fuck. Like, the thing is, I'm pretty sure the people who know how to fix this look at this, it doesn't affect them, and then they don't care. I don't even know how to. I don't know. I don't know how I go about fixing this. It is just suddenly the sensitivity is, for some reason, really low when I interact with it. Moving around the blender, it's fine. This is really slow. Maybe Blender sucks. I don't know. Maybe Blender's trash or something. How does this? Literally, Godot has this figured out. Blender doesn't. Blender surely has way more people working on it. And I won't believe that it's like, oh, it's out of Blender's hand because they use, I don't know. It's NVIDIA's fault. It's X input. It's Wayland. It's XLF. Like, I don't know what these are. There's nothing I can do to go about even understanding how to fix this. It would take me probably a month to even be able to like start knowing how to start investigating a fix for this. Like, that's how long it would take me. Gosh. G? Hello? G? I'm hitting what should be the G key. What happened? Why is all my stuff gone? Blender. Also, Blender using key labels instead of key locations. Devastating. This, it's an add-on. It's an add-on. I have the add-on. I think I get the add-on. I hit apply or something. Maybe I just type. How do I open that? F3. Okay. What happened to Blender? Why is it crap? What's happened? Go to get extensions. What's it called? What's it called? What's it called? It's not this. It's not this. I'm looking for something else. Shouldn't I still have this file? Shouldn't I have this? I found it. I would like to import an add-on. Install from disk. Gosh. Welcome. Restart of it. Did it just like delete? It just like literally deleted everything. Don't save. What happened? I don't open Blender for a month and like all these things that it's like it's a clean slate somehow. That doesn't work still. Okay. How the hell would NVIDIA drivers and some interaction with Blender cause my mouse sensitivity to read like it's super duper low? But only when I click in. Like it's reading a really low mouse sensitivity. And then I can't move things because the keys aren't right. Even though I spent a lot of time already figuring this out and I fixed it. Where's G? G. Right, like this got turned off, which I had that turned on at one point because the mouse was just getting annoying to use. I don't understand why. Can I turn this off? Can I turn this off again? I wish I could turn that off. Dvorak layout. It fails. It fails. It doesn't work. How would it not work? Failed to load key map. But why? But why? What fails you? And why are all my settings gone? What happened? It's like it actually just got wiped clean. So sad. What's in all? I just need to edit the bones. But I need to be able to move. Like I have to type in values. I have to I just deal with it. I deal with it. I just deal with it. I need it to be done. It needs to be done. I just deal with it. I deal with it. I make it work. Dissolve. Okay. Okay, what is the translation of this one? Head, tail. What? Oh, wait, I'm looking at the Z? Okay. Now what I would like is for the length of this to remain at 0.8. That's very important. The length of this one has to remain at 0.8. So how can I manage that? How can I keep the length of this to be 0.8? I mean, I guess I just adjust these to where I want them to be, and then I update the length. Well, one of them. Well, actually, that doesn't work. I would like the length to stay at that, but I actually can't make that work. Okay. Then I think I'm actually just done. Right. These are also the same length. These should be roughly out to the same position still. Yeah, like vertically or in this plane. They still go out to the same place. And now they're flat. But I would like to rename all of these to beepers. Why does F2 not work, by the way? It does work. It just didn't work the first time I tried it. Can't believe this. This garbage. I just like can't. I can't even click and use that. Like it's just insane. Okay. All right, well, I mean, that's it. So I just hit save and then I do export GLB. Is it that? So mad about that. Like that's just devastating. I have to fix that in order to use Blender. And I don't understand why that could be broken. Where am I trying to go? Where am I trying to go? Playing a game. Model. There's a blend file there. Godot game. Character crawler. It's a GLB. Okay. Big crawler. Planet game model. Not there. here. And then no animation. I think I have to leave all that on. I need to add leaf bones. Hey, I remember this one. Why? Is it like saved to the file? Is that what this is? The exports are saved to the file? That would make sense. Y up. Okay. Overwrite. And now I quit. I almost lost it. I really did. Okay, so it loaded the bones. It's fine. So I just have to... It looks like it's actually still got them all in the right place, which is weird. I did not think that would work. It roughly worked. So I'm going to, I think, just delete these ones because these ones are gone now. Just deleting them. And then I'm going to have to go through all this and I need to set this up so the settings are, yeah, so this should be front left femur. I get to go manually edit that. This is why you let... This is why your settings should be resources. Like, Godot, why'd you abandon that? Dude, they should have looked at this IK stuff this guy added, said, hey, that's cool, but also, it sucks. Where are the resources? Make those all the resources. We will not accept your commit, even though it's super cool and it all is cool and it works. We won't accept your commit because they need to be resources. Please do that. That's one of the things I don't like about Godot. So far, I see them accept changes that just are bad. They're just undoubtedly not good because they lack these things that they need to have. You know, and they do calculations. They calculate stuff. They do some calculations. Okay. Leg IK modifier. Root bone. Root bone. I don't know. So let's open up the GLB. Let's go. Does the skeleton actually... The skeleton doesn't know a thing. How does it know the bone names? It's not here. It just wouldn't be here. Just not here. Spread that... What? I have to open it. It's like Jason, right? How does it know the bone IDs? Because the bone IDs here are like in reverse. We're starting at a leaf and then we're like building up from the leaves. Why? Okay. So I think the bone IDs are staying the same. It's just that the end bones are decrementing by 1. That's my thought. Okay, let's open up Blender and count the bones. Let's count the bones in Blender. Oh yeah, Danilin, I don't know if you saw this, but this is like... I can't use Blender anymore. It's pretty much it. It like delete a bunch of my settings. I can't even load the script that fixed the keyboard layout. And whenever I middle mouse or I alt click or I click this up here, it takes the sensitivity and treats it like an inch of movement is like 1 pixel on the screen. All right, let's count the bones. And I'm assuming they're going to be counted in a particular order like this. So this is 0. This is 1, 2, 3, 4, and then there would be 5. No. Because... no. Okay, count them in reverse. Root bone 9 for front left. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Yes. That's it. Yes. 8. 9, 10, 11. There are 8, 9, 10, 11, 4. Okay, so these should all be 4 now. Front right is 3. So this one should actually stay the same. So 0, 1, 2, 3, 4, 5, 6. I've got it. Middle left. Okay. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. $19, $20, $21. Middle right. It's awful. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Shift C. Shift C what? Shift C? Shift C where? Shift C on Shift C? Huh? It's Control C. Shift C? Shift C? That's Shift C. It's still really slow. This is me using as much mouse space as I have available to me. See if you unfuck your view. It's something wrong with Blender. Maybe I need to, like, I don't know, reset Blender. I could try that. How do I reset Blender? How could I just totally wipe Blender clean? How could I do that? How do I reset Blender? Load factory preferences. Yes. Save preferences. I haven't changed anything, I think. Yeah, I shouldn't have changed anything, so just don't save. Oh yeah, I read the word. I did read the word. All right. No. The thing that sucks the most is this happens as well. That's not G. G. I can't even move things. Because the mouse sensitivity is just so low. Try middle button in the mouse. Well, yeah, that's what I use. Middle button doesn't work. If I emulate 3-button thing, it's literally this viewport thinks that my sensitivity is like 1 dpi or something. It's like, it literally thinks that my sensitivity is 1 dpi. And I can't turn it up because the mouse is normally fine. It's only as soon as I go into the viewport that it's bad. I think it's your sway setting. I don't have a sway setting. That's the thing. I'm sure it is somewhere along the hierarchy of random bullshit windowing stuff on Linux that Blender is just receiving bad values, but then how does every other application get it right? How are all other applications totally fine with mouse sensitivity, and Blender, this viewport, is just specifically not? Yeah, it's just like that. I don't know. I don't understand this stuff. All right, back to counting bones. Back left. They count them in reverse. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. This one up one. That seems wrong. Okay, anyway. $28, $29, $30, $31. All right, I'm going to assume that it should be flipped around, and this should be 31, and this should be 28, which means this one should be whatever back right would be. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23, 24, 25, 26. And the names are just gonna probably fix themselves, right? Trying out random X11 window manager. It's fine on X11 on my side. Yeah, it works on it. I mean, I think I just have to do an update, right? Like, I gotta update something. I gotta restart my computer. I'll figure it out. It's really sad, because that means until I figure out, until I can get that fixed, I can't use Blender, basically. It's I mean, I could use Blender. I could go full keyboard mode and never touch the mouse. Or only touch the mouse so I can click something on the screen. and just type in values and use arrow keys. But I don't want to use it that way. Alright, let's open Crawlerbot. Root bone index out of range. Okay. So what's the problem with that? Four is out of bounds for 4. That doesn't make sense. Oh, if I just change... Did I even have to do all that? Because it was always loading by the names the whole time. Oh yeah, and then I have to fix... I did forget that. I have to fix the fact that there's too many joints loading. It should just be that I delete one, I think. Whoops. Undo. Delete one. And then these all become... All I can think of is SpongeBob asking me, "Are you feeling it now, Mr. Krabs?" I don't. I mean, I do know why. It's like totally relevant to this moment. Feeling it now, Mr. Krabs? I know there's like a Vim way to do this fast. I don't know it. And I'm already like halfway done. Oh, the Vim way would have been to record it and then play back the recording. That would have been the Vim way. But I'm done. I'm not done. I had one more. SKI, you are losing your mind. I am. This has made me so sad. All right. And that's that. It's gonna open just fine now. It's probably still gonna tell me some errors for the bone modifier bone targets, but as long as the chain IK loads, that's what matters. Because that's not a resource. And if it fails to load, everything is gone. Okay, femur X or Z, that's right, 120, 120. Great. 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 It's like weird UI bug too. All right. So now the modifier bone targets, I just have to, I'm just deleting all of those ones. And then I need to rework these ones. Okay, it is nice that it actually prioritizes the bone name. That's pretty nice. It's pretty cool. I just now have to fix the lengths of these. Which, yeah, actually, because I had all the lengths very specific, but now these are not going to line up so well. What is that, like height with 3125, and then this would be 15625. What if I type in 0.5, 0.625? It ignores me. Okay. It says no, you don't really want that. I think there is a way to change that. But it only works on defaults where they don't then go in there and manually enforce a value. Like in this case, where they manually enforce a precision value. Okay, so instead of doing that, here's what I'm going to do. I'm going to make it too short, 0.3, and this would be 0.15. Uh, 0.32. This would be 0.6. It could also be 0.15. Or it would be 0.55. Or it could just be 0.15, and then it's pretty close there. And this side kind of doesn't really matter. Doesn't really matter. Okay. So 0.32, 0.15. Apparently some of these joints have like rescaled or something. For some reason. So that's good. This should be 1.5. Yep. Okay. And then of course the boxes. 0.32, then 1.5. tedious time. Remember, never accept criticisms for anyone. It's better to lose all your friends than to be wrong. Yeah. I mean, honestly, some people believe that. Some people actually live their life like that. Barely even an exaggeration. It would be funny if it wasn't true. Yeah, why did one of these joints just have a different transform after this? That's suspicious. I gotta sit down. My arms ache. My wrist hurts. Yeah, weirdly it was more that my arms are feeling tired than my legs standing up there. Hopefully I hit run on this and it's like perfect. I can dream. I just have a really good feeling it's not gonna work, and then at that point I'm lost. And I don't know what to do. No more crawler. Okay. So and then I need to make sure that these, okay, so these are all shared, which means I just go in here, I turn that on, that off, just so I can mark that I know that's the one that's supposed to change. This changes to this one. This changes to this. And then all the other, these don't have node A. Okay, that's fine. Yeah. Okay, so I'm still not done with the femurs. Femur bodies have been broken. And then this should be, yep. Okay, good. It's tracked it all. Awesome. This is why resources are good, because of this. This is not a resource anywhere, and I really want to share these settings with other joints. And it would just be so nice if these were resources. And I made it. I made it happen. Okay, now what? Yeah, the joints need to have the body set. That's what needs to happen. I need to assign the crawler bot as their main body. All right. I hit reload scene. Bone index out of range. Could it be these ones? It printed 6 times, which means one of these is just not right anymore. I mean, it could be all of these. Oh, and then, oh, dang, and then the tibia joints are actually too long now, too. It might just be that one of these is... I'm not sure which of these it could be. It was 6 of them, so I guess if I reload the scene and I see 5. I don't see any now. So they're all good. So if I run, it's not going to say error. Oh no, I see it happening already. What can I do? What can I do? Which of the joints exactly is the problem? Well, I mean... Okay, no, it just fell over. Okay. So it does seem like it's a combination of yaw and maybe Z on this one. So what if I turn this up? What if I just did 2 more and I brought up the 0.4? Uh, 0.4 is too much. Okay. 0.3. That was a very natural response. Yeah, okay. All right, you know what? I'll say this. Maybe it's not as bad as I think it is. They are rotated a little bit off. And it seems like there's kind of a general problem where the IK is just super busted up right now. Maybe it isn't as bad as it looks. Also, this leg is definitely just... I mean, it's not jammed into the ground. I mean, it kind of is. Interesting. That's like instantly broke it. Oh, it's caught me. Iron Lung is available digitally now. Yep. It is. Is this? I mean, maybe it's not bad. Maybe it's bad only because these motors are not trying to do anything. And that's what's bad. But the twistiness of it is pretty bad. All right. Let me activate the motors. Let's activate the motors. I don't want to do 20. I don't even want to do 18. Like there's too many, not enough performance. I've been applying it this whole time. I am doing velocities. No, I'm not, because I have this at 0. 1. Do 1. No, your legs can't just break. They can't just break like this. Can't do this. You can't. Because it's just too twisted. It's way too twisted. It's way too twisted. Alright, let me try this. Target velocity. Use half of this divided by state step. The smaller value between cities sine times absolute value over delta. Min f with 0.5. Okay, what now? Too few arguments. Update motors. Hmm. It's actually so sad. Like, these are just so horribly twisted out of place that it just can't do anything. It really just can't do anything. It's stuck. And it really is just because those joints are just twisting. They're just twisting too much. All right. Here's what I'm going to say. During the solution for this, I am going to teleport bodies back on. I'm going to forcefully teleport them back. So yeah, I'm going to do like solve joint position, all the joints, and then I'm going to do solve joint motor on all the joints. That's my idea. And positions are just going to be to, yeah, forcefully teleport the rotations back if they don't have. You see the final solution? No. So this is my solution. If a joint's rotation exceeds, I could also do this up here in the process modification. I could correct it here. I can set the bow and pose rotation, and then because I'm always running down the chain, then I can teleport the body that this represents to match that. So that's what I'm going to do. I'm going to leave this stuff written like that. And what I'm going to do is I'm going to look at, yeah, I'm going to copy the rotation of the joint to the bone pose. And then I'm going to hard snap it, I guess. Or what am I thinking of? Because essentially the idea is up here I have the error. So I can save the error up here, but then I need to fully correct for that. It has to be fully corrected. So frame to frame, the physics process might come back and give me stuff that's a little poorly rotated, but then I'm gonna step in there and say, no, it needs to be fixed. So I'm going to the skeleton should, okay, this is before the skeleton has done any IK. This is after the skeleton does IK. I need to, how do I do this? Just the main problem, no matter what, is that there is like technically, I mean, I guess it's fine, right? Like I need that to happen. I'm not finishing my thoughts. I need to rely on the physics server to come back and not totally solve everything. Okay? It needs to not solve everything. It should solve a lot, but it should not solve everything. So I come in here from the rendered result, which is what I kind of don't like. I don't want to work on a result that's already been rendered. I'd rather step in after the physics server ticks and say, good job, not good enough. I'm going to do some final corrections. Maybe that's what I need to have. Maybe I would like to be able to insert just after the physics server steps and really correct for positions and velocities as like a hard step, I guess. In this case, I know that I can because I know that I'm going in a specific order. I'm going to leave the body where it is, and I'm going to teleport the first joint to snap it into place to where its bone connects to the body, and snap any rotations. And then I'm going to go to the next body and snap that to the end of the other one, and then correct for its rotations, and do it in that order. I'm going to do that for all of them. So it should be okay in that sense. I'm actually looking for... No, yeah, I am looking here. No, I'm not looking here. Where am I looking? I need to go to... It's in main. Main. I really don't know which one I should do. Just open the file. Let's look for... I don't even know. Step. Iteration. Here we are. Physics process. And then physics process. Physics server step. Flush the message queue. Iteration end. Right here, I would actually like to be able to have a callback after the physics server runs, where I can say, no matter what, I want to fix something. Ideally, I would have a signal, but I don't know how to have a signal here. There's the get main loop. Well, I guess it's the get main loop iteration end. I could put a signal there. But I think the issue with that one is I probably... Yep. I think maybe what I want is instead to have, right in this section, I would do... I would probably do get main loop and then call something on the main loop. So if I look at main loop, it just has this stuff. But then I have scene tree, which has this. I suppose it could be like a process frame. Well, no, I don't think I need to worry about that. It could be here, where I set a Boolean on physics when I get the physics call. And then I have a process that all it's responsible for is snapping everything together. So motor runs, the angles come in, I assume that they've already been snapped. Physics process happens, the whole space updates, and then I set a Boolean, or no, I set a Boolean physics process, the space updates. I get into process, my Boolean is true, and then I do the correction. The problem is that I could run more than one physics step in a single frame, which is actually really likely. Because I'm doing 100 steps, which means if the frame rate drops below 100 FPS, I'm guaranteed to be getting multiple calls here in a row. So I'll be losing stuff. Is it possible that Rigid Body has some special thing that calls it at the end of the frame? No. Do I need to do this? Is there a way I can get around it? It has to be in the physics area. But the other issue is that I kind of don't even want a frame to render where it's out of place. I don't even want that. I mean, I could probably still just set a Boolean to do that anyway. So at the start of my physics process, I can, I guess I check if the Boolean is true. If the Boolean is true, then that means I'm calling it again before I even reach process. So I need to snap there. And then at the end of the function, I set it to true, or I just leave it as true. And then process will set it to false and then run the snap again. And yeah, and it set it to false. I guess I can do that. Because the purpose is just so that I don't even get a frame to render of it being out of place. Which even means interpolation, because if I'm getting 150 frames per second, then I really need to make sure something is snapped into place. Alright, maybe that's what I do. So physical skeleton is a node that gets process. So I can still, yeah, so I can still run process. So I think what I'll do is I'll do this. Process. If joints, if snap joints, I call a method. What can I do? Like, I'll do this. Has physics ticked? I'll call a method called snap joints and set as physics ticked to false. That's all this does. And then a process modification. I'll collect up all the errors. Well, preferably I collect the errors and then I possibly snap and then I apply the rotations to the bones. I could also use this as the callback for when joints are displaced. Snap joints could be responsible for calling this. That sounds good. That actually sounds good to me. So yeah, I run up here, I say if as I need to make this a method. A method? A variable. If has physics ticked. I call snap joints. I need to make snap joints a method. It'll be up here. I say up here, down here. If physics has ticked, snap joints, and then this will be responsible for doing basically all of this. But then I have to run through and do this every time. So yeah, I'm going to kind of copy all of this. It's actually, wait, this is actually a lot that I'm moving around. So I'm going to move this here instead. So that all of this removal and delete stuff is shouldn't really move in the code. Okay. And this will perform this. So I would have deleted them from joints by this point. So this is up here. Does this really not use anything? This only uses the bones. Okay. Yeah, because I have to collect all the errors, call out, and then I would. This would be like, actually, this still doesn't fix it. Damn it. This doesn't. Well, I think this can still probably be at the end, but then I have to do snap joints, which will connect and do the callouts for things to break, possibly. But I do need to break them before physics. I don't know. That's fine. Because either way, I have to wait for a physics tick to come around again to realize that something has moved too far. So like the joint would be in a position that is broken when it comes back, and then I would destroy that joint, draw the normal stuff, and then physics would run on that broken joint. And this is the case where the joint is out of place. I reach process, and at that point I decide the joint has to break. Should I just have... It would just be simpler if I had something right here on iteration end that would be like a signal. That would actually just be fine. That would be great. In fact, I want it. I'm gonna do it. Where's scene tree? Is it in core? It's right there. I just am blind. Oh no, it's scene main scene tree. Okay. Yeah, I'll just make it so iteration end. We'll just do a signal so I can connect to the scene tree signal when it's done, and then I can do snap joints in there. Yep, this is what I really want. This is what I really want. Because anything here, it's always called at the end, and I always know if I'm destroying a joint, and I don't have to do this process, Boolean, check, reorganization. I just do it. I just fix them all right there. I can still read in, break them, and at the very end, I snap them. And that's what I do. And the snapping doesn't need to know because I've already processed the errors, I've already processed breaking them. All of that. No. No. Is it? Wait. I don't know. I'm over my time. I don't know. When I run a physics frame, it's possible it's already rendered. I want it to happen such that I don't render even a frame of it being out of place. But how could it get out of place so quickly that a frame would happen where it's in a ridiculous and obvious position Obviously ridiculous position. If that happens and is noticeable, it would have broken on the very next frame, physics frame. So you would see it in the weird place, and then I would break it, and then it would continue flying off where it was going. That's what would happen. So a small problem the physics frame comes back and it's in a weird spot. I come back in the next frame and I push it back. What this means is that for small angles, it will kind of always stay in this like slightly slumped position. Or at least visually it would appear to. But yeah, I also think I don't even want the frame. So maybe I do just stick with what I'm doing right now. Physics frame comes in. I check if I want to break anything by getting the errors. I do the breaking. And then maybe the difference there is in the physics process. I say, collect the errors, you're allowed to break it here. But if I also do that in the very next frame that renders, so it doesn't even render out of place, that's the, okay. I'm just gonna do, that. Yeah. Okay. I'm going to take a break. A long break. But I'm going to come back because I actually want to keep working on this. I want to see it looking like it's made of plastic and metal and not looking like it's made out of jello connected with string. Okay. I'll be back. I am back. All right. What am I doing? I am get the errors, save them. If I'm going to delete them, I delete them. So I'm just going to drop it. I'm not going to use snap joins because I'm not calling it there. Moving it back up here. No more has physics tick. Just not doing that. There's a weird copy that just happened. Was it a weird copy? What is happening? I think I just have to tab everything in. I think that's what's happened. But it's weird. It's not... Oh. Yeah. No, I get it. Delete that. I would disable them. I would delete them. And then here... I would... Sorry about that. What is this awesome life-changing profile I found? Is this AI? Is it like an AI filter? Is that a mask? Cool. That's cool. What I am doing... What am I doing? I'm doing... For body and disable... Is this correct? I don't know. I don't know what's right anymore. What's right? What's wrong? This code has moved. It's a mask thing. All right. Okay. So I delete everything, I get all the errors, and then I would copy. Or rather, I can do it up here because I know it's not going to be... Yeah, if it would be removed, I would ignore it. If it's going to be... If the joint's going to be removed, I ignore it. But then I think what I really want to do is I actually want to leave it and do... Another iteration? Yeah, I need to. Because I don't want to do anything for joints that are like removed, I guess. Because, I mean, what's going to happen is this is going to be... We go up the chain, we disable them. So they're still part of it, and I still want to do snapping, but they're disabled. But then if I remove something, I'm also going to remove all the children. So that's what I want to be sure about. I want to be sure that when I'm doing snapping, I'm only doing it on joints that are actually attached to the main body, because that's like a large mass and it's like one joint working against like the whole rest of the body. Like 2 kilograms working against 30 kilograms, 38 kilograms. So that's why that motion is, that swing, I mean, that's probably why the swing basically can't even be solved. You would need tons and tons of iterations so that this one would move the main body a small amount, and then that would continue on to all the other joints with a huge ratio. And they have to feed back into each other, so if it was like 2 joints like nearly equal mass, it'd be no problem. But I think the problem starts because one joint is connected to a heavy mass. That mass is already much heavier than itself. And then there's 6 of those. Yeah, that's what I'm going to say. So I want to keep these low. In fact, since I've been doing this, I might be able to drop them even more. I might be able to go back to like 8 and like 10 and 10. I'm going to try that. Once I get this in there and I can clearly see it's working, I'm going to drop it to like 10 and 2 and see if everything is still snapping together well. Especially once it gets on a spring. The main body's already on a spring. But then once the legs are on springs, it means it won't really be contacting a static body. So if I do any snapping, it pushes it into the ground a little bit. That'll just be the spring to handle that, which can push back on the whole body. Okay. So we go through here. I would get, what is my idea? Snap joints not found. Right, I'm just deleting this. Deleting that. So I'm always going down the chain. So I'm starting at the root. So the first one I get, the parent should be the main body. So I'm getting the parent rotation, I'm getting the actual parent rotation bone. So what I think I mean to do is, well, okay. Let me think about this. How do I limit the axis to rotating in 1 degree? I mean, I guess I know what that is. The limits are all based on Euler angles as well. So, you know what I'm going to say? I think I just run through. I look at the joint limitations, and I snap them one by one. So, no, I shouldn't do that. Maybe what I can do is I can take... How do I do this? I can also just look at this code. This code has a limit here. Let's close that. I'm looking for joint limitation cone 3D. It does this. Direction angle to center axis. Center axis. Okay. Can I actually just call solve on this? Does a joint limitation allow me to... Why would it? Why would it? Okay. Joint limitation. Local forward vector, local right vector, rotation offset, local current vector. We're fixing current vector by doing make space, rotation offset, forward vector. So we're just creating a basis out of that. We're just creating a basis out of the axes. And then we're transforming the rotation offset by that axis. Okay. And then we get the direction relative to that space, solve it, and then transform it back to that space. Okay. All right. I need to open CCDIK. Oh, it calls get limited rotation. Dang. Right. Forward vector. No. The middle term is being fixed. I don't know if I need to go this far. It is just that I provide a forward and a right vector. I guess I need to know what those are. That's probably the issue. I don't really know what those are. I think this is an iterate IK. It's got to be iterate IK here. Get limited rotation. Call solve with the forward vector. Limitation right axis vector. When this solves and it's 0, what does it do? Creates a quaternion. pointing up. Axis Y. Times... I don't know what a quaternion made with 3 vectors is. That's just an axis and a rotation? I guess. No, yeah, what is that? Odd. Okay. The offset and then local vector normalized. I get it by taking vector and getting it relative to offset, which is the it should be relative to its default resting position, right? So I get it in terms of its resting position. And use the forward in that one. Forward. Forward. I think is also just its rest position, actually. I think that's what forward is calculated to be. Right. Snap vector to plane. Get rotation axis. Axis is the next one, origin. That's the direction. That's also its length. How does it limit based on... Because the IK still has it locked by axes. This isn't done here. This is actually just a cone. Okay, so this is not the place. Get projected rotation is what I'm looking for. Snap vector to plane. Axis local vector. Get rotation axis vector. X returns the X, Y returns Y, Z returns Z. Also, it normalizes it, which is whatever. So I take the axis local vector, I rotate it by the offset. No. I take what? This is the parent, or yeah, this is his rest. This is what it is. So I'm taking the vector relative to its rest. I take local vector, I extract its length, I do snap vector to plane, which I'm sure is just called a slide. And then I take projected, normalize it, multiply it by length to retrieve the length. If local vector and the axis are nearly aligned, what? Interesting. Interesting. When they are nearly aligned, we just skip it. Which also, this line should probably move up here because this code is all... In fact, this should go all the way up here. This should be moved like 5 lines up. Okay, so I just take the offset, which is the parent's rotation. I mean, it was so simple. Okay, so I still get the parent rotation. If it's the body, I need to get the bone rotation. I get it in terms of its parent. So now I have that. Then I want to get it in terms of its rest pose. So car horn. So the other thing I want to do is I want to teleport it to this location. I want, I guess basically just to take the error of this. Oh, I guess this is actually the rest post. This actually gives me the orientation of the body relative to the parent and what this is like all error, right? And then it should be on those planes as well. So now I'm thinking, well, its connection to its connection point to the main body should always be a fixed location. Yeah. It should always be a fixed location. This is like completely the error here. So actually, I'm even saving it as offset. Let me save this as the error instead of offset. Or I just have so much stuff here, but it's, I mean, it's not that big of a deal to just keep track of it all, right? So yeah, take joint body relative to its parent. So this is like treating it as its rest. So any angle from here is a change from its rest position. So if it has a Y rotation, pretty much any rotation that's off the axis, the one axis it should be allowed to rotate on, I can just remove that. But now down here I have joint offset. So I don't really have to do most of this. I already have the offset. I have it relative to its parent. So I can just do, I'm also not gonna do only rotations. I'm gonna say joint data angle. Yeah, so I'll fix it and then I'll run motors based on the real difference. So there's that. And then I'm not just doing rotation, I'm actually doing set pose entirely. So I want to fix the, I'm going to fix the position. And that's going to be oh. That needs to be this. That does need to be this value. Also, I don't know why I'm doing all of that. That's kind of just extra for no reason. None of that was used. So yeah, basically what I want to snap it to this location. So I get this location. I am doing a recalculation, but I don't know. So it's going to be this location. So I take where the joint is relative on the parent and take that by the parent transform. And then I want to get this in bone pose space. So that would be taking this position, which is in global space, and just doing it by, yeah, the skeleton global transform verse. So I get this. And I think I can just type origin here. So I've got that. I've got the bone rotation from the last calculation. So I should have... What's the error here, by the way? Why is it? Why am I allowed to provide a quaternion? That's really strange. I feel like that should be an error. Yeah, that just provide bone rotation, I think. Cool. Though I'm not sure, so I'm just going to write basis anyway. So now this is relative to the skeleton, and this rotation would be relative to... Oh, no. Okay, so what I want to do is I want to do set bone rotation to this value. This is relative to the parent. And then I want to do skeleton set bone set bone global pose. I should just call it one time. Really, I should just be doing set bone pose. I should just obtain this position, which is now relative to the skeleton, and get that relative to the parent bone. That's what I should just do. There we go. Okay. So I get this relative to the skeleton, then I get this relative to its parent bone, and then it's there. Can I do get axis join to rotation axis? Okay. Get joint rotation axis. I can do that. I think I have that. If I don't, I can have that. Yeah, I have the setting ID. It doesn't know the joint ID. But I can know that. Just save everything. Not there. Set up joints, IK. I know that's a joint. I know this is the setting, and then I know this is the joint ID. There we go. Got it. I could also just save the rotation axis. That would be the only reason I want this, but I guess for now it's fine just to do this because then I can just look it up. And then I'll later have to say, oh, well, I also want this thing, and then I have to save everything all the time. I just save the IK. Also, this only matters if it is IK. So I still want to snap it there. And then if joint data is IK joint. Also, I don't think I care about doing snapping if it's disabled. So no, I do care about snapping if it's disabled. If it's here, then it means it's still attached to the main body. But if it's IK is the only time that I need to do angle stuff. Rotation axis vector? Oh, vector's probably better, right? Okay. Setting. Joint. If it's not 0, then I do... I'm just going to follow the path. So I normalize it. I already have it relative to the parent, so I don't need to do that. But I probably should run this. I should check if the local vector normalized dot the axis is close to 1. Wait, what is it? I have the axis, I have vector, local vector is... Doesn't, can't I get that? Can I get this? Get axis. The rotation axis of the rotation represented by this quaternion. So when I do get axis, is that like the forward vector? Because the way I think of a quaternion is it kind of points a direction and it tells you how far around that axis it's rotated. Sort of, but also not really. That's how I think of it. Is that correct? The y axis is the way that the bone points, right? Well, the axis there is just bone position is the position of the parent. Well, yeah. It's where it should be on the parent. So I take the joint relative to the parent, and I treat that as where the bone should start. But that's... Or... That's relative to where the bone should end. So... I have to get the, this is where the bone should end. Oh, man. Okay. This does have to be IK for that. Because I have to know where the next location is. Well, hang on. Its position... I have its position and then its rotation already, relative to what it normally would be. Its rest pose. And all I really want to do is just snap it so that it's not rotating on the Y or anything like that. So bone position is actually, yeah, where it starts, and it would be relative to its parent bone, which is what I have. Okay. So then this would mean that this is going to be the up axis, right? Alright, what does it mean to get the axis of a quaternion? Because if I can just skip this and that's like the up axis. I mean, it's actually probably not. It's probably based on the forward axis, right? trace. That would be 3 plus 1 is 4. Square root get 2. Temp 3 equals 1. S is 0.5 over 2, which is 0.25. And those will just become 0. Okay. That doesn't help me. Well, I guess it means that if the basis is no rotation, then it outputs a 0001 quaternion. Okay. So now get axis. If W is greater than zero. Okay. So then that's not nullable. If W is nearly 1, it just outputs a 0 vector, which means no axis. Okay. Alright, so yeah, I do have to use the basis out of the bone rotation, which it's actually just this. So I should probably just write it like that. Though if I am doing it like that, then I probably shouldn't even use it at all. This goes up here. Okay, so yeah, I'm actually just getting the Y. The axis would be the up axis from here. No, because I think axis is, wait, axis is the rotation axis. Oh, no, if it's aligned to the rotation axis. So I'm looking for a local vector, which is the offset. It's rotation rotated by its offset, which is its rest rotation. So it's bone rotation. So I'm looking for local vector to be this is what I want. Yeah, offline multiplayer. That's what I was trying to type there. The y-axis. Should be the y-axis. So then if local vector normalized, I know it's going to be normalized, so I don't even need to do that. Dot rotation axis is approximately equal to 1. So if it is not equal to 1, then I can snap it, which would just be doing this snap vector to plane, which comes from somewhere. What? Chain IK. IK modifier. Skeleton modifier snap vector to plane. Cool. That means I have that one. I don't have that one. All right. I get the length. I normalize it. I take the vector, normalized, slide, that normal. And okay, I mean, I know what I'm doing. It should be length 1. Which means I'll just multiply by 1 again. That's not how that works. That doesn't actually retain the length of it. For that exact reason. Yeah. Interesting. That's actually wrong. I mean, it's definitely wrong, right? I already know it's 1, so I just do local vector would be local vector slide out the rotation axis. And then I would scale its length up to 1, or just scale it to 1. How does that work like that? I'm really confused now. Because slide will make it shorter. Slide just subtracts its dot. But then I need to make sure it comes back up to 1. But this just looks like a weird thing. This would just mean, oh, that's why. Do that. What? Let me write that. Yeah. Scale it back up to 1. So then I have a new forward. And I'm actually really confused. How does this stop it? This actually doesn't stop it from rotating around the y-axis. Is this an IK thing? Yeah, because now I need the right axis to correct for the rotation. So this will be the new forward. Okay. Well, this is the new forward. That's a guarantee. And then its right axis will be the rotation right axis vector. None. Am I crazy? How many times am I asked that question? Yes. The right axis of positive x is negative z. Do I have to specify this to fix that? Has it been an IK thing this whole time? Or because it doesn't have this right axis vector, it doesn't know how to limit it doesn't know how to limit that axis? I mean, I don't think so. Because the default is to use, when it comes in as none, the default is to use... Okay, I still don't understand how this works. But maybe this works. But I think I should have been giving it that right axis this whole time. At least now what I can do is on my side, I have my new forward vector, and I know exactly what the right axis vector should be, so I just pull that. Yes, I think I have to do this so that I can correct for it, and then, well, actually, I guess I could just call vector normalize. That's exactly what this does, isn't it? Yeah, just run normalize. So I have a new vector, and then what I'm going to do is I'm going to say bone rotation. Bone rotation is now going to be I'm back. Okay, that new new forward. New bone rotation will be a basis created from if this is the y-axis, Wait, the right axis vector should be... Well, I think it's part of the limitation. I have this... I have this slid out of that plane, which means that vector is the 1. Right. Okay. So I'm not looking for rotation X. Well, I sort of am. Let's see vector. Iterate IK get joint axis. Get that, and then if axis. I really wish it would like rotation axis X. Then I would say bone rotation is basis. Using that, the local vector, and is this correct? I meant to be using the Y for these, right? Yeah, I think so. And then the Z-axis would just be local vector, the right-hand rule. Yeah, 1 second. Dog is still barking. I'm back. Right hand rule. I don't remember which way it is. It's like point, thumb, and then this is the way that it goes. But I think it's actually the other way. Point, this, and then your thumb points the way that it goes. I had it wrong for a long time. Okay. Point that way. That's the up. So In this case, I'm doing the right axis that way up. Does that work here? Should just leave them all hidden. Up. I could do this way, that, up, right? Rotation axis is Z. So Z, forward, forward. So yeah, forward, cross, Z. This one's the cross. Forward, cross, yeah. And then this one, I guess I can construct it any way I want. Forward. It's the same thing again. Forward cross with. But also this one doesn't work. You can't do that. You can't do that. Because I'll be sliding out that and getting nothing back. So, all right. Rotation axis. Yeah, this one's weird. How would you make that one work? You can't. You can't make that one work. Because that's your up axis. How does this work? Get projected rotation. It gets this vector, rotates it by here, which this is the up vector. This is the y. So yeah, how does that work? Literally, how does that work? You would have to represent your vector as a quaternion at that point for any of that to even work. And the question is, how do you slide? How do you... whatever. I'm going to ignore it. If it's not there, then it's not there. And I'm just going to say push error. I don't know how to do this. I'm just going to say I don't know how to do this. And return. Okay. Yeah, I have no clue what that would mean. because I'm taking this as I'm taking this. So if the rotation axis is the x-axis, then that axis should always be oriented that way. If the rotation axis is the y-axis, that axis should always be oriented that way. So how do you... You don't. Okay. I mean, I guess you can. I just wouldn't do a slide, right? I do this slide when it's one of these. Otherwise, the local vector should be I mean, I think basically what I do is I take I think it's like I take a basis. I construct a basis using yeah, okay. So it's about like this. Instead, the local vector is actually going to be, I'm going to be taking the x and the z axis. I'll take the x and the z axis. But I guess what I can do is I can take there's something that was like you construct a transform or a basis from something from like two vectors and you provide an up vector. Is it just this? Looking at such that forward z points to the target position and the up axis points as close to the up vector. Okay. Z negative. implies positive x is left. Okay, so I think what I do there is I take, all right, I do basis looking at. That's what I've been looking for. Can't I just do this for all of these? I think I can. I could just do basis looking at. Let me see what that is. It's got to be here, right? Okay. I think that's it. I think I can just do basis looking at for all these because it does the normalizations. Up is not normalized, so I need to make sure that's normalized. Target will be normalized. Yeah. Okay. I mean, I think the slides are still probably fine. Yeah, I'm just going to do it for this one then. So basis, looking at target, will be I mean, I don't know. What I think it probably is that I take the incoming x and z vectors, I project them to the y plane, and then maybe that's it. And I'm going to write my own. No, I don't really need that, do I? I'm just doing that. If either one of these are nearly pointing that way, then I guess I pick the one. Oh, maybe I pick the one that's least aligned? Or that's most, yeah. I think I actually pick the one that's most perpendicular to it. And then I would take... Hang on. You know, I give up. Honestly, like... Is it Dave? Oh, it's... I totally got it wrong. I'm sorry, Dave. I'm afraid I can't do that. That's what he says. All right. So if the axis of rotation is on the y-axis, I don't care anymore. I don't care. How would you even limit that? Like, because I'm looking at this other code. I don't see how it can limit on that. Because when I get projected rotation, I just take the vector, which is the up vector, and I slide out the up axis. So now it just has nothing. Okay, well, these are always the same. This comes back. I get the y, which is the direction it's pointing in. And then I slide out the rotation axis. And then I create a basis with that being the up, this being the right, or whatever, and then crossing it so I get the other axis, and then I get that as a rotation. So now bone rotation has been fixed. And then I set that back. And now I'm gonna run, and it's gonna explode. It looks like it just totally crumpled. Basis 0, 1, 0 must be normalized. Huh? How does that make sense? What are you talking about? Why are you telling me the z-axis is 0 when it literally could not be 0? It could not be 0. Wait, am I thinking of this right? Hang on. Did I do this wrong? I did. I think I confused myself. So I'm taking... This is axis on the z-axis. So I'm taking that, crossing with... Yeah, I'm dumb. I'm taking that, crossing with z. Which this is positive z. And this is... Yeah, but why did it, like, say that it was... Well, so that's funny. It must be normalized to... Would it be casting quaternion? Use... Get quaternion. Yeah, okay, whatever. Okay, interesting things are happening, but I can't see it. I'm also really far away from it. It looks like it's not actually doing it as well. It looks like it's definitely not fixing it. Which is sad. Why would it not be fixing? Let's bring the player closer. Okay, so first of all, the IK is really bad. Oh, I'm also not teleporting the bodies. That would probably explain it. Okay. What I'm gonna do here is I'm gonna step through this and see all these run and check what the results are. So I get the right axis vector, or I get the rotation axis vector, so it's Z axis. It's not 0. Since this actually all comes from here, could I just make this a method? I think I'm just going to make this a method. This will make it a lot easier to have fewer returns. Rotation axis is 0. Return. Normalize. What are you mad about here? Bone rotation is not declared in the current scope. So then if this is approximately equal, return. All right. Okay. Also, this is technically relative to its rest pose. So maybe I need to transform it by its rest pose. Yeah, because it's basically aligned with its rest pose, right? So yeah, I've actually made a little mistake there. I can transform more Quaternion, right? What about a basis? What about a get bone rotation? There's not a way that I can just tell this. Can I do a quaternion multiplied by this? No. What about basis? Alright, whatever. So it's technically already relative to its rest, then I need to get it relative to its rest. And then I'll just step through this. Well, maybe I want to start out here before this call. Well, no, because I already have it. So I can look at all this. Joint data. It has no offset, no angle. All right. So snapping should just do nothing. So obtain the rotation axis vector. I take this one, they're not looking at each other. And I take local vector, which is just... That's not what I expected it to be. Is it? Wait, is it what I expected it to be? Yeah, I guess that's actually right. It shouldn't have rotation yet. So when I slide it, nothing should happen. And then the first one has the z-axis. So what I end up constructing is... It should just be a basis that's totally normal. It should just be a completely normal basis. Yeah, that's totally normal. So then I would take its bone rest and rotate by that. Good. Something, right? And then that's the angle, which is just nothing. Oh, no, 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 no. No, 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 no. No, this is up there. And then I do that. Okay. Which actually, that's what I was doing before. But also bone rotation was different. No, it was this. What? What was this? Bone rotation is parent inverse. I get the main body. I get its rotation in the space of its parent. And then I set the bone pose rotation. Which actually the first... Yeah, these definitely have a rotation from the parent. How does this work? This was the correct code before. That was right. And maybe it wasn't right. Let me try this. Let me call, before I set bone pose, joint data, bone ID. Let me do this. Okay. So I think this was all right. Step out. Bone rotation is just no rotation from the rest position. I say that as the angle. Then I calculate this as being what the rotation should look like. And then I expect to see last post to just give me the same value. Sort of. So bone position is correct. Bone rotation, I can't really read that. Can I do get bone position? Yeah. Have I been wrong? I feel like I've been wrong. Of course I am. I usually am. Okay, so this is what I've calculated for bone rotation and bone position, and this is what last pose looks like. Good. Those match. Okay. So the first frame, they should match. So I'm going to take this off, and I'm going to step a few physics ticks forward until we land. And I see stuff start moving. Stuff is not collided yet. Okay. I'm gonna go one more. Oh. Okay, now I'm going to look at this. I think I was wrong before. I think I was definitely setting the pose wrong. Wow. I was definitely setting the pose wrong. Okay. So I get this local vector. Okay, cool. We're pointing in some direction that's not normal. Right? We are not aligned with that vector. Normalize this one. Oh yeah, slide out. So slide and then normalize. So local vector was offset basis y. This. So we had some rotation here on the z, which would mean I'm not exactly sure what that means. Anyway, it did do something just now. It did get rid of something. So it should be on the z-axis. So what I expect to see is, I mean, I expect to see it just come back with some rotation. Is this how quaternions work? It tells you the axis of rotation there. Like it says, oh yeah, we have a little bit of z rotation, and this is what it is. Is that how this works? So last position, last rotation, and I'm going to teleport it there, which it looks like it detached a little bit. Which is not what I would have expected to see. But that is a very small value, so maybe it doesn't mean anything. Okay, so current rotation is this. Bone rotation, last rotation. Interesting. Interesting. What does this mean? This means I don't know. I'll go to another one. So this should be the next one down the chain. So it should have an x-axis rotation. It is currently pointing let me like model this out in like a new 3D scene. Can I just translate this one? Yeah. Just change type to a marker. Why are you unhappy with this? Recommended not be transformed. Fine. Sure. Okay, so this one is going to be at this location. Right? Okay. So now it should be rotating the x-axis, which means this x component should go away. Right. And I'll model also the one of these with like some rotation and model the new rotation. Just make sure it's all going the way I expect it to go. So we slide this, so now we end up with this value. And it's normal. That's not normalized. It is normalized. It's just being weird. Okay. So original. This is going to be snapped. Right? So now it's off that axis. Let me make these larger, like a meter. Okay. And then now I would be constructing a basis, and now I want to see what that basis is. So now I have copy value, and then I would have basis. Right. Now it looks like this, which just has the smallest Z rotation ever. Right? Okay. That looks good to me. So current bone rotation, last rotation. I'm just going to... The positions are odd. The positions are getting... These numbers are too high, it seems. I don't know if that's right. Right. I'm fixing the bones. I'm not fixing the bodies yet. That's kind of silly. All right. That is silly, man. I need to actually fix the bodies too, not just the bones. Okay. Yeah. So I end up with the position. So I end up with this stuff. I think yeah, let me say body position should be, so I want to copy this one and look at this actually. Whoa. Oh, no, this is like the new one. Copy. These other ones. It's hard to like... I guess I'd be looking at the z-axis to be different. No, the z is... It would be the x-axis is different. Right? Yeah, it's really hard to see. All right. But I am forgetting to teleport the body. So the body position should just be moved to where... Should just be moved to this location. It should just be moved here. This is where the body should teleport to. And then I have... I end up with bone rotation. And this is going to be the allowed rotation. Right? Hang on. Because this doesn't include the axes that are free to spin. I think that's probably part of it. Oh, yeah, yeah. Because I even look here and I say, here's like the actual error, but then I have the, yeah, okay. So on the axes that are allowed, this should come back corrected. This will be this rotation is going to be what's allowed, right? So I would just say body rotation would be, I need a global rotation, so it would just be taking the, okay, let's just say parent transform, so I need both of these. And then I'll just drop that out. Parent, origin. And I'll just say joint data, body, global transform. Will be equal to, I guess it would actually be equal to, can I do transform rotated? Axis and angle. Yeah, I don't think so. Teleport it there. And then give it, wrong way around. Teleport it there and give it a basis of this should just be global. So, or yeah, it is like that. Transform basis translate bone rotation. I guess I just construct a basis out of this. Whoops. I was trying to save this scene. I don't want to save the scene. Have I saved the scripts? Yes. Take that off. Continue. Step a few frames. Until things start moving. Okay, I think it's doing stuff. So I want to see what's happening. The z-axis, local vector. Yeah, I assume whenever I get something on that axis, then that means I've built up some errors that I wanted to, that I'm cutting out, right? And that is a pretty small value. Yeah, it's 6/100ths of a centimeter. You can think of it like that. Then I slide it out. Now it's gone. And I guess what I'd be looking for is to see like how much rotation this really turned out to be. So I should be setting the body. Okay, so I want to see what this changes by. Joint data, body, transform. So these are the angles. Maybe I go to quaternion because then it's only 4. Or, I mean, Euler would be better, I guess. So I want to see that this should barely change, but it probably should change. I should probably see a change, but almost nothing. But it's going to kick me out of this when I click forward. Yeah, so then I don't know if it changed. It looks pretty different to me. I think it does look really different. I guess I can look at what these values are. See how much that really changed. Because this seems like it might have moved a lot. Position barely changed. Rotation does have kind of a dramatic change. I mean, not really. These are like very small value changes, I think. What about this? Okay, it's going from 6 degrees to that. But also the Y orientation is not changed, so that's good. Yeah, I'm not sure about that. That's seems like a lot to me. Next one. Well, I guess what this means is I'm correcting. Yeah, if this is the offset and I correct it forcefully all the way, this would be the angle offset. I don't know, it's hard to know. if it's really working or not. So I'm just going to hit continue and see. So one of these seems to have rotated in. Okay, that's really not good. Oh, that's crazy. Maybe the teleporting isn't a good idea. And his joints do seem to just be phasing through the world very, very easily. Damn, that's stupid. Okay, maybe I don't fix the position, maybe I just fix the rotation. I force the rotation to not break. But I feel like I want to fix it no matter what. I guess one way I can fix it is by measuring... I don't know. This sucks. This is way worse than I was thinking it might be. I was thinking it would be like maybe sometimes it would pop or jump out of the ground. This is just... I mean, how is this even happening? Like, that's not supposed to happen right now. That's not supposed to happen. Do I have a mistake on that joint chain? Z is the one the axis is allowed to move on. Maybe the torque is way too high. I mean, it's possible. I could just fix the torque. Like, genuinely probably should just be like 20. Is probably all it needs. That should be all it needs. Is 20. Yeah, that joint is specifically twisting out of place. It's the front left. This one. This one's rotating way out of what it's supposed to be able to do. Why is it wrong? It's the only one that's wrong. Why? Quit opening this. Don't. Okay, get out of here. Go away. Stop that. It's open like 10 files trying to get me saves. I think I need to wrap it up and stop now. This one's really odd. There's just some weird setting in here on the front right, or the front left. Somehow there's just a weird setting. But everything seems right. Yeah, this is just weird. When I push it, the leg snaps. What? I'm very confused by what's happening. In one case, it like snaps inside of me and it can't leave. And then another case, I can push it like it's just totally normally physically simulated. And then it like dangles. And it also just doesn't, it just refuses to move the IK in general too. The IK refuses to do anything. And this is just so wrong, because like what I do is I come back and I teleport, the body teleports back. I teleport it. So it's not even doing the rotation correctly. And it's also like, is me moving it messing with it? This is really weird. Like, I don't get how my teleporting it could be interfering with it, actually. I don't see how that could be happening. Because what you would think is that I teleport it into place. The system thinks that it's trying to move it in that direction as well. So then I take one frame, and it's actually come further away. Okay, I've got to go. Like, I've actually made it worse. It was better before I did this. Right, well, thanks for watching. That's it for today. I'll be back tomorrow. Hopefully with an idea of what this could be. So I don't have to sit there for 10 more minutes and ponder this. Yeah. Alright, well, thanks for watching. Goodbye.